I just don't get how you could use the stars to prove the shape of the ground. You're using globe measurements and a optical sky map together to prove that they kind of debunk the claims of the measurements of the Earth, but that's still globe measurements. Like they took those, so you're appealing to their measurements.
So it's about proving the null hypothesis, though. That's what it really is about. His null is that it's H naught, right? Is that the Earth is a globe. H1, right? The Earth is not a globe. That's the null. So you're trying to prove the null. And how you prove the null is if you get any corresponding angle measurement that has a flat baseline, it can't possibly be a globe. So it's not necessarily proving the shape of the ground, it's proving what the shape of the ground isn't.
Yeah, but that method has us above a star at a higher elevation than a star. That's real shit or what?
Bro,
Oh, that's
Mike has
good.
already told you that you can have a negative angle. And it's the same,
Yes,
it's
he
the same
said,
principle.
he said that would put us above the star. Yes, he said it.
Optically.
Yeah, optically, it doesn't
You
put
guys
you
are
above the
saying it's
star.
geometric. I know shit optically. You guys are saying it's geometric though.
A geometric measurement of our perceived space. For example, it's like the star, when we look at it, is going down, but that's because our eyes are making it going down. What it's doing is it's going further away. Just like if you're observing an airplane getting closer and closer to the horizon, it's getting further away. It's not getting lower, although it does look like it's an inch off the ground. And we can say if we were in the
Why are
right.
you teaching us apparent fucking position?
So it's not in the geometric position. And celestial theodolite says stars are in the geometric positions and the mountains. Now you're
Yes,
saying it's not.
You're
That's fine.
comparing it to the geometric position being what it was at that time. You're comparing the time, right? So when they took a zenith measurement to get the GP of the star in the first place of whatever star you're looking at. You're
right,
comparing the
because
time.
This
it's
method has you at a
curving,
higher elevation than a star.
and the elevation is
Now
not
you're
the
just gonna
true
repeat
elevation.
that like a mantra, just Jeremy. It doesn't mean
Because
anything. What you're saying
it
doesn't
does
mean
mean
anything.
something. It does mean something. It means that if you use this stupid fucking method, we're a higher elevation than a star. That's what it means.
It's stupid to you because you can't comprehend it. That's not my
It's
fault.
stupid because I don't think we're above a star.
You're
Ever.
not above
Yeah,
the
me
altitude of
This
the
either.
method
star.
has us above a star. Are you guys
You're
fucking
not.
dense or what?
No, we're not, because you're confusing angular elevations in degrees for actual elevations. In astronomy and cosmology, when they talk about elevations of a star, they're not talking about how high it is. They're talking about angular in degrees elevation. You have to redefine the term elevation in your
exactly.
head. You have
Yeah.
to transpose your use of the word elevation to its appropriate application. In this context, when it comes to physics and astronomy, an angular elevation doesn't mean how high something is. It means how many degrees it is from the horizon.
Okay, dude. By this method, the celestial theodolite method, where you're saying everything's in its actual geometric position, the star and the mountain. When you have the negative angle, even that Heffron guy admitted, it would put us above the star.
Not physically.
Yes, physically, we would
No,
physically
it
be
doesn't,
above the
because the
star.
star's higher
If
than
everything's in its
us.
Christ, you guys
No matter how
don't
low
fucking
to the ground
understand
it
this.
appears, it's still higher than
Do
us.
we understand it, Jeremy? You're
It
basically.
does let you.
All right.
Sorry. Go ahead, Rick.
Jeremy, would you say the same thing? Jeremy, if you're on a mountaintop and then you're higher than another mountaintop and you see an airplane intersect with that other mountain, are you going to say that you think you're higher than the airplane? That's your argument?
If I was claiming that the airplane was in its actual geometric position and it was below
Angular.
my horizontal, yes, I would say I am above the airplane. That is
And
how
it's at,
actual positions in geometry works.
Well,
it's
that's
at
retarded,
30,000
Jeremy.
feet.
That's
It's
not
at
retarded. That's
30,000
how
feet, and you're
geometry
not.
works.
It's at 30,000 feet, and you're not. The plane is at 30,000 feet, and you're not. You're below that. You're 30,000 feet below him, yet you're taking an angular measurement, which he's only, from your perspective, from your eye, from your measurement, he's only an inch off the ground, but you know he's 30,000 feet.
This is why I told you guys. I don't know why you're using the term geometric position, because you're making this confusion.
It's geometric in the sense that you're drawing straight lines from the center of your azimuthal field of view.
It's optical though, Sean.
Horizon elevation, yeah. It's not geometric as in like you're physically matching or higher or whatever than the actual jet plane. It's imagine a compass, not the kind that you navigate with, but the half dome compass, the flat part on the bottom.
And we get that stuff, bro. I'm just
Okay,
saying, like,
that's
you're
what we're
drawing lines
measuring.
to an apparent position. When you guys say geometric position,
Yeah.
you're saying that it's actually there.
Yeah, but see, the thing is, Jeremy is uncomfortable with drawing straight lines to stars because then technically you can guess a height, right? An altitude of the star, but we don't care about
Well,
that.
that's
Because
not
the
why. That's
idealized
not why.
altitude is
Beast.
6210.
That's
That's
not
it.
why. That's not why I'm uncomfortable with it. I'm uncomfortable with it because now we're above a star. That's what I'm uncomfortable with.
Like we're above the jet plane because
Not
it's at
in
our eye level.
reality. What are
In
you talking
reality,
about?
Geo.
We're not actually above the fucking star.
Okay, let me ask Geo this. Geo, if everything's all geometric and everything's in its actual position, and I draw a horizontal line with something, it's right at my eye level, right? That thing in the distance?
Yeah, it doesn't mean it's intersecting with the ground. It could still be thousands of miles up or feet or miles in the air. What's your question?
My question is if everything's geometric and there's no funny business going on and everything's in their actual positions, and I draw a horizontal line to something, it'd be right at my eye level, right?
like the jet plane that we said, right?
Hold on, man. Let me just walk Geo through this real quick because I don't know what's the problem is here.
Yeah, the only thing, I'm about to drive through this area where I might have spotty reception, but we can try. It'll be about 8 minutes until I'm in better reception.
Just talk to
But-
him, Geo. Talk to him. 'Cause
Well, if I cut out or start roboting, I'll be back in like 8 minutes. So going
I'll let
through
you
this
know.
one part. But go ahead.
If everything's geometric and I draw a horizontal line to something in the distance, and that would be at my level, at my eye level, right? It wouldn't be beneath me, it wouldn't be below me, it'd be right at my eye level, right? I'd be at the same height as it.
Not necessarily, not if it's due to perspective.
Oh,
Like
when the sun
everything's geometric. What do you mean?
sets,
Everything's geometric.
When the sun sets, it's not hitting the ground. It's thousands of miles or however many feet it is up in the sky. It's setting
Okay.
due to the perspective of objects dropping due to the way the eye works.
We're not talking about anything like that though. Just something in the distance. You're in your backyard. There's something in the distance in your yard, and it's at your horizontal. It's at the same height as you, right?
Do you like want to throw out perspective completely, Jeremy, or
It
what?
sounds like it.
First
It
of all,
sounds like
perspective
it.
doesn't do what you guys think it does. Perspective
Like-
just means things are in their geometric position.
Like
If you're
the
saying
railroad
things
track.
aren't in their geometric position and perspective is knocking them out of their geometric position, then I wouldn't go around claiming that all the stars in the mountains are in their geometric position.
They are, like just like the railroad tracks are in their geometric position, but they appear to join due to perspective.
So what?
They-
They're actually there though. If you shot a bullet,
So-
if you put a can on one of the tracks and you shot a bullet at the can, you're gonna hit the can because that's where the track is.
Get it, but the railroad tracks are joining at a distance due to perspective.
So
It doesn't
what?
change the
Everything's in
fact that they're not. It doesn't change the fact that they're in their geometric position. It doesn't change that. It's just an apparent convergence due to optics. That's what we're measuring here.
the railroad tracks, just because they're converging doesn't mean anything. If you put a can on top of one of the
But
rails
they're not.
anywhere on the track, yeah, why aren't they in their geometric position?
They're not converging.
Computer. All right, Jeremy. It's very simple. Okay. When we say true geometric position, all right, we're referring to the actual time of when that star would appear to be at your zenith, according to the nautical almanac. Right. That's the angle difference. That's where that angle comes from, comparatively to its apparent position. Right. With celestial refraction, 15 degrees plus or minus, etc. That's the difference.
So when you say they're in their actual geometric position, you mean they're not really
You're-
in their geometric position. They're in some apparent position, not geometrically.
No, it's based off the timing. Okay. 15
Dude, are things in their
degrees.
geometric
15
position or not?
Are you listening, or are you just trying to challenge me?
I'm trying to just figure out what you guys are saying. Are things in their
Okay,
geometric
are you
position or
listening?
not?
I'm trying to explain it to you.
Okay, well, I'm just going to ask that question after, but go ahead.
What are you going to ask? So you're not going to listen, so I'm wasting my time.
I'm going to listen to you, but then I'm going to ask my question if you don't answer it. I don't know what to tell you because that's a big question for me because if things are in their geometric
What's your
position,
question, Jeremy?
when we look at the star and the mountain, are they in their actual true geometric position?
Yes, the mountain's in its true geometric position, and now we're using a star, and we're tying it together. Okay, how are we tying it together, Jeremy?
So the star's not in its geometric
I'm
position.
asking you a question. How are we tying it together?
I still don't understand the thing.
Hold on. I need to understand if you know what, like, if you understand the process.
I don't understand.
How
I'm
are
trying
we?
to understand it? Are the stars? Is the star in its actual true
I'm
geometric
asking
position?
you a question, Jeremy. Please answer it. How are we tying the mountain and the star together?
By the timing.
Including
Now let me ask you a
By the
question.
timing.
Are the stars
Okay,
in their
cool.
actual geometric position?
By the timing in relation to what the GP of that star is, which makes essentially a right angle triangle because the star is above the ground somewhere. So there's an angle
Exactly.
from where that star hits the ground from where it is from your perspective, seeing it at an angle.
Okay,
Right.
so
The
is the star in its true
flatter
geometric position?
doesn't match the actual elevation
Christ.
angle taken with the theodolite to the mountain. The
Well, that's a separate
elevation
thing.
angle taken with the theodolite was 2 degrees
Yeah.
and 19 minutes. The flat Earth trig was 2 degrees and 31 minutes.
Well, we can go on to that, but maybe we should just do that next because until we finish this.
I want Jeremy to understand this. So the timing, right? When you're seeing that star get occluded, right, and you're taking that snapshot, somewhere on Earth, there's someone that can take a GP of that star and and it's right above them overhead. It's a zenith measurement, okay? That is what we're linking the timing to. Does that make sense? To him, it's 2 degrees. Let's just say 2 degrees 31 arc minutes. That's the angle from his location to that star. But when you take a snapshot in time, you're comparing the true geometric position, which means where that star would be at your zenith if you were right underneath it. That's the comparison. Its apparent position comes out to like 2 degrees 46 arc minutes. You may not like the concept, but I personally love it because the responses that we've seen towards it from the globe side has been insane.
Well, it's because
If the flatter stick doesn't match the real observation, how is it not refracted?
Yeah, but dude, if it's 50.7 kilometers away from your location, you don't think that things can appear to converge because of some type of optical effects, right? You're basically shooting at the Adelaide 50.7 kilometers away, right? That shit's gonna look concave, convex, whatever. They say that it matches the globe angle, but just like how Jesse takes shots to mountains 75 miles away, and he says, "Oh, that matches the globe angle." Okay, well, in our interpretation, it's curved visual space, right? In the globe interpretation, it's Earth curve. Things drop over a distance because of Earth curve. Well, we say things drop over a distance because of curved visual space. So how can you basically determine which one of those is correct? That's the point of the celestial theodolite.
Yeah, I don't care what the point is. The fact is
I'm
that
explaining this to
I
Electric.
can't. I
Jeremy.
know. All right. Well, can I say my thing or?
Yeah, go ahead.
Okay.
All right, thanks.
Can I say first, Jeremy? There's two reasons that things drop. One of them can be actual altitude drop, like that's one reason that something in the distance could look like it's actually dropping is because it is actually dropping in altitude. The other one is just to be simple, I'll use the word perspective. Something drops because of the visual space in which the object is not changing altitude, but it's dropping due to perspective. Like when you get to the equator, Polaris is not hitting the Earth, or when you see a sunset, the sun's not hitting the Earth. That would be perspective. But if the sun actually did drop out of the sky and hit the Earth, it would also look like it's hitting the, intersecting with the ground. So I kind of think that's what you're maybe conflating in the two, is whether it's because you're trying to say if you're above the mountain, you're actually above it, which is not the case. Like same with that airplane. If the airplane was intersecting with a mountain that was lower than you, the airplane is not actually lower. You're not above it. That would be due to the optics. It's not actually lowering in altitude. The airplane's not crashing into that other mountain.
Okay, so if you were to say, I see the plane and it's in its actual geometric position, and you made a horizontal, and the plane was below the horizontal, you are above the plane.
Okay, so what?
Okay, so we got that straight.
So you're at 30,000 feet.
Yeah, so I guess you're apparently at 30,000 feet when you see an airplane hit the horizon.
No,
I magically jump up in the air 30,000 feet, Jeremy. Why? Oh, well, that's what the angle tells me.
Do you guys know
Are you
how
on top of
geometry
Mount
works?
Everest? Are you on top of Mount Everest looking down at an airplane that's like 10,000 feet?
That's ridiculous.
Yeah, I know how geometry works and I know how it works within curved visual space as well. It can be applied to curved visual space.
Curved visual space,
we're
is that where
observing
things
the-
are in their actual? Oh, Jesus
That's
Christ.
when you see an
You know I'm
airplane that's
trying to-
I didn't even
30,000
finish my
feet
question. I don't know.
off the
Somebody else
ground,
started talking. Now you're going to
and
answer my
then
half question.
you're looking at it,
I'm
and you
trying
know
to
it's
make a point.
30,000 feet, but you're looking at it and it looks like it's an inch off the ground. That's due to curved visual space. You could take a geometric straight line from yourself and run it to it, even though it looks like it's an inch off the ground. Its true elevation is 30,000 feet. Its angular elevation may be
Oh,
a
why
couple
you guys
degrees.
explain perspective to him, dude? He's a flat earther, dude. You guys are not like
It
understanding
is
what
weird.
you're saying is wrong, and he's right, and he's just. You guys just need to stop saying geometric position. I told you that. That's the problem.
Like, dude, if everything's in its true position, and you make a horizontal line, everything below the horizontal line is below you. That's what true geometry does.
Depending on how far it is.
Okay.
No, not depending on how far it is. That doesn't matter. It's forever. Geometry is geometry. A straight line, everything below it is below it.
It could still be a straight
You guys
line.
are fucking confused or some shit.
No, it could
You're
still
the only one in here confused, Jeremy.
I used to navigate for a living. Ships. I'm not confused. I understand how these straight lines work due to perspective and for
You
navigation.
clearly don't.
Stars.
You definitely don't.
I do. It's a straight line. It's just that like again with the example of the airplane, it's at eye level, but it's 30,000 feet high. It's just you're taking a straight line shot with your instrument, for example, with your sextant, and it's going to give you a straight line measurement in degrees.
Can I clarify something here? I'm trying to get my head around.
Yeah.
Sorry, one second. Push to talk wasn't working. There is no measurement actually being taken with the celestial theodolite except for the time.
Yep.
There is no negative degree below horizontal measurement that's ever been taken in the celestial theodolite. Am I wrong?
Yeah, you're
Correct.
wrong. You're
Correct.
wrong.
It's
absolutely wrong.
Like Heffron,
It's only
in the
time.
last presentation, he had one. He did have one that was a negative angle.
Yes.
Remember that?
Yep.
Yeah.
But that's not the important
Now
thing
he
because what
agrees.
you're actually
Now he agrees. He just said wrong, but now he agrees. Okay.
No, he said that, but that is the timing. That is the measurement that matters.
Yeah, so there is no
not the angular in
negative.
degrees.
If you go look at those graphs, there is no negative there. It's all because it's got nothing to do with actually taking a measurement with a sextant or whatever the other tool was that I think he's used. It's all just to do with you as an observer watching the clash of two images off in the distance, the mountain and then the star. Right, that's the two images that you're looking to interact with one another from your visual point of view. It's got nothing to do with you actually taking a personal measurement and saying that it's below anything or anything like that.
I just remembered another question whenever I can get in.
Well, let me get it. Let me say, yeah, there was one that he had that's negative in his graph. I hear you though. I mean, some of those angles are the calculated angle, and I don't know whether he was with that one that was negative, whether he had a sextant or theodolite that actually took it, but we could go on that in a second because there was several numbers in his graph that he was showing in the last. So we could talk about what that was. But I just want to say real quick, Jeremy, like, let me just say real quick with the airplane thing. I just want to say this, like, if you're on the ground, there's an airplane 30,000 feet in the air, and there's a mountain that's 10,000 feet tall, and the minute the airplane intersects the mountain, there's a straight line between you, the mountain peak, and the airplane, right? The airplane's at 30,000 feet. That's like the celestial theodolite thing, except you're using an airplane. And when you know the airplane's at 30,000, you get the intersection, straight line, geometry, everything's good. Now, if you then go to the top of a mountain, you're at a 10,000 feet mountain, and there's a 5,000 foot mountain off in the distance, and then that same airplane keeps going away, and it occludes that 5,000 foot mountain. Does that mean that you're above that airplane just because you're looking down at it? No, the airplane's still at 30,000. You're at 10,000. The other mountain's at 5,000. The actual real elevation of the airplane at 30,000 feet is intersecting optically with the 5,000 foot mountain, even though you're at 10,000 feet. In that whole scenario, you're not above the airplane. You're 20,000 feet below the airplane because you're on a 10,000 foot mountain. The airplane's at 30. However, with that whole thing I laid out, remember the first thing, when you were down on the ground looking at the airplane at 30,000 intersect with the mountain peak, you still had a straight geometric line. So it's like both are true. It is geometric when you're on the ground, like the celestial theodolite would be a straight line. And then the other scenario, you're not above the airplane. So that's kind of the conundrum.
There's no conundrum, Geo. If you draw a straight line and you say everything's geometric and you draw a straight line and something's below it, that means you're above it.
It is geometric when it's positive, yeah, when it's in the positive. When it goes into the negative and it's that far away and it's intersecting with a horizon, you're dealing with an optical drop due to perspective.
Okay, I wouldn't disagree with that. I wouldn't disagree with that. However, these guys are saying it's all geometric.
It is when it's up at an angle like that.
But
There's
they
no
have
problem
one
with
that's
that.
below you. So the one below you is not geometric, but all the rest of the ones above you are.
Hey, guess what? Then that's when you wouldn't use celestial theodolite to make a claim. That's why Dr. Mike included it in his spreadsheet to challenge Jesse. Because guess what? It still matches more towards the flat Earth than the globe.
I don't
with
care
that
what
same
it matches,
concept.
bro. I don't care what it matches. The method has us above.
Yeah, you don't care. You seem
Because
to,
the
you
method,
seem to not care,
quick
Jeremy.
question.
I don't care because
Planted
the
your
method
feet in the
has us
ground
above.
and you're being stubborn, bro.
I don't
Yo,
care
Jeremy,
because
I
the
don't think
method has
they're
us
getting
above
it.
the
Jeremy,
star, and
I don't think they're getting it, dude.
Quick-
I don't know why. I don't
quick
know why
question.
Guys, let's go one at a time. Just hold on, queue up. Don't just come in to say random things like people aren't getting it. Let's just let people go at a time. Jeremy, go ahead. Say your thing. If you want to get in, queue up, get in. But
like a bunch of times. Like they're. I don't
I
know
know,
why
but just
no
the
one.
random
clarifying
comments we don't need right now. Just let Jeremy respond.
if you're doing geometry and you draw a straight line, things above the straight line are above it. Things that are below it are below it. This method has us above a star. That's why I don't care about it.
Dude, but
So,
okay, let me
question?
say my thing again.
Oh, man.
You have an airplane at 30,000 feet, you're on the ground, and there's a mountain. The airplane intersects the mountain. It's a straight line, right angle triangle. If you want to call that geometric, the airplane is in a position. That's all good. Then you get up on a 10,000 foot mountain to bring your scenario in, and then there's the 5,000 foot mountain, and then that airplane off in the distance after it's traveled and dropped in apparent altitude due to the angular drop of perspective. Now, when it intersects that 5,000 foot mountain, you're still not above it. So the fact that you're seeing it intersect that 5,000 foot mountain when you're at 10,000 doesn't negate the fact that when it was at 30,000 and you were on the ground looking at it with the mountain peak, that you still had straight line geometry.
Okay, Gio.
So you're trying to, it doesn't debunk it. It doesn't falsify the first thing. The fact that you changed all your scenario and you got up on a mountain, you did all this other stuff to then get a negative angle to then claim you're above it. It doesn't debunk the original right angle triangle when it was up in the sky.
Okay, we're on a 10,000 foot mountain. We draw a straight line out. There's a mountain beneath it. There's a mountain beneath that straight line we got, right?
Yeah. 5,000
Yes,
foot mountain.
Yep. So the mountain's below us.
Yep.
And you're saying everything's geometric. The plane, the mountain, everything's in its geometric position, right?
It's our 10
it
overrise
is-
overrun, bro. That's it.
Hold on, beasticles.
Sorry.
Is the plane and the mountain in its geometric position?
In what scenario? When you're on the
In
10,000
the
to 5,000?
scenario you laid out, I'm on a 10,000 foot mountain. We draw a straight line out. The mountain ahead of the mountain in front of us is below that horizontal line. Is the plane and the mountain in its geometric position?
AKA, are you asking is light
Hold on,
traveling
man.
straight?
Shut up.
All right.
Let's all just stay calm. Keep cool. All right.
Well, I'm
I
in
love
the
when
queue.
Jeremy whispers, "Shut up." It's hilarious. Shut up. I can't argue loud with my wife next.
Everyone's fucking sleeping here. Shut the fuck up.
Well, dude, I just think different things happen when you have something that's like setting off in the distance. Like if you're on a 10,000 foot mountain and then there's a 5,000 foot mountain and the sun sets intersecting with that 5,000 foot mountain, you're not above the sun. Are you going to
That's
claim
why-
you're above the sun? I mean, the
No,
weird thing
Gio,
about this
I'm
is it
not-
gets into like a
Gio,
globe
Gio.
argument, actually, but we'll
Gio,
pretend
I'm
you're
not
not.
the one. Gio, I'm not the one claiming the sun's in its geometric position. I wouldn't do that because I wouldn't say we're above the sun. These guys are saying this shit's all in their geometric position.
Define
Question.
geometry. Define
I got a
geometry for me.
question.
Define
I got a
geometric for
question.
me.
Dude,
Hold on,
one
wait.
second.
Let's let Rick get in because he's
Thank
Yeah, I
you.
mean,
wanted to ask.
Is the negative measurement that you looked at in that graph, is that a measured value or is that a calculated value?
It's calculated.
There's no measurements, bro.
The
in this
negative is calculated?
Yeah. Well, I mean, yeah.
How can it be
it's-
calculated? If the null hypothesis is the presumption of like flat Earth, and then you're looking at a point in the distance, and you've got to assume it's higher than you, that's the whole calculation, isn't it?
Well, it's gonna produce a negative angle just based on the geometry. That's the part that Jeremy is challenging. Well, if you do that, then now the method is invalid. But it's like, okay, what can you use the method for? What would that even prove if you use a negative angle? The only reason
Sorry,
why he
dude,
did that was to satisfy Jesse's question, and what I guess now is Jeremy's question.
Yeah. Okay.
I don't have no
Look,
questions.
dude,
I have no
how are you
questions. I
ending up?
understand that. Go ahead, Rick.
If you've just got a baseline and you're drawing a triangle right up to the star, how are you ending up with a negative value? If you've got
because Jeremy's talking about going up in a mountain and looking at another spot of land that's off in the distance that's of a lower altitude, and then seeing the sun intersect there. I mean, what was the Mike Heffron's? The one that he had negative. What were those locations? I don't remember offhand.
was that peak to peak?
I gotta get. I gotta pull up the spreadsheet.
I just gotta know.
So Jeremy, you're not making none of this is linked to a globe argument. You're just trying to say that because of this, it just debunks like the whole thing. You're not trying to say you're above it because of a globe idea. Because some of the globe guys might try to do
This has
that.
nothing
They're
to do
trying
with
to
the globe. This has nothing to do with the globe. This has to do with geometry and drawing a straight line out from the mountain and having a star beneath that straight line. That means we are above the star. That's what that would mean. That's what these guys did because they're claiming everything's in its geometric position.
That's why I asked. That's why I asked if they're trying to steel man
I
the
think-
globe. That's why I asked to begin with. Are they saying that because they're like trying to compare with the globe model? Because when you use words like that, this isn't the stars in its geometric position when it's including, then you're claiming the globe model, which is what Jeremy's problem is. If you say we're taking like straight lines to apparent stars, then Jeremy wouldn't have this problem, and neither would I.
Let me explain something. Real quick. When you're using the nautical album, like when they first created it, they basically took zenith measurements. Okay, why did they take zenith measurements? Because those are subject to the least amount of celestial refraction. So now they link that to a certain time, right? Based on the vernal equinox, the first point of Aries, etc. You can have any arbitrary starting point, doesn't matter. But you're basically tying that star to a relationship with the sidereal rotation. That's what you're doing, right? So we're basically comparing and contrasting using the timing of when the star actually disappears from the observer physically and linking that. And that's what we say true. That's what we mean by true geometric position of the star is its true position in time. Right.
But then you're conceding the globe model because you're conceding where they think geometrically these stars are, and also that refraction is the only other thing they need to account for once you get rid of that.
It's not the globe model. It's the celestial sphere model. Okay, so the celestial sphere.
It's in the geometric position is the globe model.
Dude,
No.
it's not true. You don't even know what's going on.
You can
Oh,
still
you
have a
don't have
position
to
above. The shape of the ground doesn't make a difference of that position of wherever the star the angle is. I don't think anyone's making a claim where the star is, whether it's light years away or 1,000 miles or 8,000 miles. Nobody's making that geometric claim. We're talking about the angles, the optically observable angles, and how those align with the GP and the mountain and the ground and the observer. That whole relationship, which can reveal components about the shape of the layout of the ground. That's the whole point.
And then Jeremy's
How
just
else all
gonna keep repeating they have us above a star like a fucking
Because
mantra.
you do. This method has you above a star. Just because you don't understand it isn't my problem.
In degrees.
In degrees of optical view of something at the distance. Yes.
That's a big difference. Yep, big difference.
Gio, I'm not
Jeremy,
saying
just
it is.
dude,
These guys are saying everything's in their geometric position. How hard is this? You draw
What
a
does
straight line
geometry
out.
mean?
I know you need to interrupt me. You draw a straight line out. Everything below it, that straight line is below it. Everything above it is above it. They have a star below it. That means you
It's just
are
not how
above
that
the
works.
star. In the celestial
Doesn't make you
theodolite,
below it.
in this celestial theodolite thing, it does because they're saying everything's in its geometric position.
What does geometric mean?
It means actual, real position.
No, it doesn't. Look up the
So
word
it's not in its
geometry
real
and geometric.
position.
Look up the word geometry and
But you guys
geometric.
turn off the refraction corrector, so it would have to be in its actual position.
So it's not in its true real position. Beasticles just told me everything was in its true real position, true geometric position.
Based upon its apparent position, it's in its true position. Yes,
Based
not
on its
that we,
apparent position, it's in its true position. That makes a lot of
because
sense.
the way we see is the fact that you don't get that. This proves that you're not including how we see in curved visual space due to
Yeah, that
perspective.
means
Oh, I'm
apparent.
just
So it's
taking
apparent.
geometry into account because you guys said everything's in its geometric position.
Geometry
So I was
doesn't
doing
say-
geometry.
You're misusing the word geometry altogether. There's 3 different types of geometry. Number one, and none of them have a definition that just means things in reality.
So okay, so these mountains and stars, they're not in their actual position then.
Their actual position, as far as actually where they're at, we do not know.
Bro,
Where
I
they
don't know what's
appear
going on,
within
dude.
our
Geometric position. I looked it up. Geometric position refers to the location of a point or object in space. Literally, like the point in space, not anything, not apparent, nothing apparent, nothing optical. Literally, where the object is.
But
Geometrically.
everything in the sky, including the celestials' bodies, are apparent to us. We don't know what the
Exactly,
fuck
so
is in
don't
the
call it
sky. We're just
geometric
making an angle
position.
relationship. It's just an angle
Yeah.
relationship. It's
Yep.
basically
That's fine. That's fine. But once
Geometry
you say geometric
deals with
position,
angles.
you're
If you-
literally saying it's in that position,
Yep, it's
which
lines
is then the
based on.
globe model.
no,
There's
dude.
nothing to do with the globe.
Yes.
It's where it is in the celestial sphere.
That's
Which
all
is
it
above
is.
the
So that,
ground.
yeah, exactly. So don't say it's a.
Do you think the
it's a
celestial
geometric
sphere
position?
is
It's
the
just an
globe?
apparent position.
Are
They're
you taking a
using
globe
geometry.
argument?
Celestial
What?
hemisphere, if you want to say that, above the ground. 180
Yeah,
Yeah,
degrees
but if you
around.
say it's in its geometric position, then it's not. It's a full sphere.
You're using sine, cosine, and tangent angles, and that's geometry. Geometry is a mathematical study of those lines.
I think we're going in circles, dude. I don't think anyone. I don't know. It's weird. Beasticles. I'm curious. Where does he get the fudge factor? What is that?
Oh wait, you just to say you're going in circles, then just shut the combo and shift to something else. That's not.
Because we're just
Yeah.
going in circles. Like no one's.
It's not circles. He was just describing something about geometry. You interrupted him.
Can I get my opinion on the topic? I don't know if I'm.
Do you want to finish Shire Farm? Shire Farm? Do you want to finish what you're saying about geometry?
No, that's okay.
All right.
Finish Shire Farm? Shire Farm. Do you want to finish what you were saying about geometry?
No, that's okay.
Can I give my opinion
You
on the topic? I don't know if I'm.
Do you want to finish Shire Farm? Shire Farm. Do you want to finish what you were saying about geometry?
No, that's okay.
All right. Real quick. I just posted a picture of.
Well, then we should. I guess. Are we going to shift though? We're going to shift. I guess. I mean, Q-Op did have his point, but I just didn't know
Well,
if is Jeremy out of here, or is he still? Because I don't feel like we got to the bottom of that.
Dude, so the star and the mountain, they're not in their actual position then. Is that not what you guys are saying?
Well, Jeremy, I'm sorry to have to repeat it, but let me just ask you this again. If I'm on the ground and there's a mountain and then there's an airplane at 30,000 feet that we know is at 30,000 feet, you would agree with me, we could draw a line, like take a fishing line or something, from my eyeball to the top of the mountain. You know, in theory, I know that it would have sag to it, but in theory, it'd be a straight line. Then from the mountain to the airplane, right? And that would all be, you know, what you're calling geometry, like physical. You're making a straight line with an airplane.
Yeah, if you're saying
would-
everything's
okay.
in its geometric position.
Hold on, let me just finish. Hold on. If you agree with that I'm on the ground, there's a mountain in the distance, there's an airplane, we know is at 30,000 feet, we know that I'm, you know, at sea level, we know the mountain, let's just say 10,000 feet, and there'd be a straight line.
Okay,
You could
but I
take
have
a
a
fishing line or whatever from my eyes to the mountain to the airplane. And then from the airplane down to the ground. So you could
Okay,
have
are
another fishing line. Let me just finish what I'm saying. You could have another fishing line going down to the ground. So you have a triangle.
I have a
You got
question about this part.
fishing line. So but I'm just saying, in that way, you're making an actual right angle triangle, you know, planar surface, right angle, all of that, right? And then just a second. Okay, go ahead. Go ahead.
Are we seeing the mountain and the plane in their actual geometric, actual real true position?
Yes. In this
Okay,
scenario
then
I'm laying
yes.
out, yes.
Okay, then yes, we draw a straight line to it. It's all lined up, sure.
Yeah, because that's why I said using fishing line from my eyes to the peak of the mountain,
Okay.
to the peak of the mountain, to the airplane. Like it's physical 100%. Now, if you then just go up to the top of that 10,000 mountain, now there's another 5,000 mountain in the distance. and the airplane is still at 30,000 feet. I know I said this before, third time, sorry, but and then the airplane now, when you're intersects with that 5,000 foot mountain, you wouldn't claim that the mount, you're at 10,000, the mountain of the distance is at 5, the airplane's at 30.
Okay, Geo.
Even though optically the angle could be negative, there's obviously something else going on there. Even though the first scenario with the fishing line to the right angle triangle, that was all legit with the plane at 30,000. But now that you're at a 10,000 and then a 5,000 foot mountain and then that airplane, there's obviously something else going on. So one doesn't debunk the other. It doesn't mean that the first one is faulty because the second scenario has a negative angle. There's obviously something going on with that negative angle. Yeah, go ahead.
Geo, once we're on the mountain, is everything still in its true actual geometric position?
For the 15th time, yes,
Hold on, that was
Jeremy.
for Geo in his plane
Jesus.
scenario.
Yeah, it's pretty wild, dude.
He said yes.
Well, everything is in its position, but
Are we
there's
see-
a
hold on,
different
Gio, are we
there's a different effect happening though because it's off in the distance.
Okay, so we're not seeing everything in its true actual geometric position then. Once we're on
We're
top
going
of
to
the
jump
mountain.
you.
Hold on, man. So Geo, once we're on top of the mountain, we're not seeing everything in its true actual geometric position then.
That's what I was going to talk about.
Hold on, man. Let him answer.
Wait, what's your question? Well, okay, if you're on the
Once we're
10,000
on top of the mountain, are we still seeing the plane and the other mountain in its true actual geometric position?
No, because you're dealing with a negative angle, which brings
Okay,
it.
but these guys are saying, I know, but these guys are saying
All right,
this shit's
Jeremy,
all in its
here.
But
these
those
guys
are two
saying this
different
shit's-
scenarios. The one they're doing is not a negative angle. The one they're doing is just a right angle. That was the first one I said. When you have the fishing line, when you're on the ground, the mountain, the airplane, the fishing line, there's nothing faulty about that. Just because you go into this negative scenario that brings in another factor doesn't mean that the first one was faulty.
Okay, I don't know anything. I don't know if the first one was faulty or not, but this other one, if you take the fishing line and you say you did say everything's in its true actual geometric position when you're on top of the mountain, and you took the fishing line and you made it horizontal, everything below that line is below you.
It's not when it's setting on the horizon like that.
I know, but I know, Geo, but if you were saying that it was all in its geometric true actual position, everything below the fishing line would be below you.
Okay, but nobody's claiming that.
These guys are claiming so they're not claiming that all these stars and mountains and shit are in their true actual geometric position. Okay.
Well, they're in their angular geometric position when they're above the ground. Yeah, I think the negative thing brings another factor into it. But dude, Mike Heffron was showing in that chart though that he had the globe, even with that negative angle, he had the globe prediction and the planar Earth, and it still was closer or fit the planar versus globe. So there's a difference in those in terms of the mountain, how it should be tilted away. I just think that I hear what you're saying. I just think the
He's just
link
making a
that you're
semantic
making.
argument. He's making a
It's like
semantic
an-
argument. It's weird.
It's not semantic, it's geometry.
It's like an equivocation. I don't want to have to call it a fallacy because I'm not saying you're purposefully being fallacious, but it's like an equivocation for two things that are not able to be equivocated. Like they're different because when you're going into negatives, you're dealing like something negative on the horizon versus something at a few degrees above the horizon are just different scenarios in terms of like what's involved.
Okay, so in the celestial theodolite thing, when Mike Heffron did it and he's on top of the mountain, the stars and the mountains and shit, they're not in their true actual geometric positions then, right?
They're still in their optical. I mean, when you keep saying geometric, are you talking about tangible, physical?
They're true.
nobody's making
wherever I'm talking about where you see them is where they are.
Yeah, the true position in the celestial sphere due to the angles and the GP on the ground. But nobody's making a claim like that the star. See, I was trying to use the airplane, which is a physical, tangible thing, in the analogy I was using, but still is an angle. As an angle, the star, no one's really. When you say true geometric, do you mean like the actual tangible physical star, or are you talking about the angle in the celestial sphere?
I'm talking about the actual position, the actual place where you see it. That's where it is. If I were to take the fishing line and stretch it out,
That's still not enough.
It would be right where the star is with the fishing line, just like the plane you wanted to do with the fishing line. I would see it right where it is.
Can I read something to you, Jeremy? Can I read something to you real quick? I want you to read this paper. It's a short guide to celestial navigation, and I tagged you in 2 parts. Okay? I'm going to read this real quick. If the Earth's surface were an infinite plane, visible and sensible horizon would be identical. It says, in reality, the visible horizon appears several arc minutes below the sensible horizon, which is the result of the two contrary effects, the curvature of the Earth's surface and atmospheric refraction. The geometrical horizon, a flat cone, is formed by an infinite number of straight lines tangent to the Earth and radiating from the observer's eye. Since atmospheric refraction bends light rays passing along the Earth's surface toward the Earth, all points of the geometric horizon appear to be elevated, and thus form the visible horizon. If the Earth had no atmosphere, the visible horizon would coincide with the geometrical horizon. There's two
Okay.
things.
So what?
Sensible, and geometrical horizon.
Dude, in this celestial theodolite thing, why don't you just answer this question for me? In this celestial theodolite system, is the star is the star where we see it? Is it in its true actual position as we see it? That's
In
where it
what
is.
model?
And shut up, dude. In the celestial theodolite method.
Why are you guys gatekeeping this
I'm trying to ask
conversation?
Beast a question. I'm trying to ask Beast a question.
And you need to ask him in what model.
No, I don't need to ask him in what model. That shit doesn't matter for this.
Okay,
It
Gabriel,
matters.
just let him finish his engagement. Just let him finish his engagement, then you can get in and say your piece. Let him just finish. I mean, they're just trying to stay on it. Go, just say you can come in after, but Jeremy, just finish your.
Beast, are the things in
Right.
are the things is the star in the celestial theodolite method? Is the star actually where we see it? Like as we see it, that's where it actually is. That's its true position. Is that how it works? Yes or no?
In reality, yes.
Okay, so if that's how it is, and
The
we're
true
on top of the
position,
mountain,
apparently. Yeah. Uh-huh.
true
You have
position,
a
apparently.
negative angle. Yes, it's okay, Jeremy, to have a negative angle towards it. Yes. I don't want you to repeat the
Yeah,
same
you can
thing.
have a negative angle and then you're above the star. That's fine. Yeah,
Where are you
You're not
concluding
you're
you're above
above
it?
the star. You just want to keep saying that over and over again, dude.
guys.
Yeah, I don't know why you're saying you're above it.
If you make a
Because, dude,
horizontal, Geo,
well,
if you have
when
a
you get to the
Geo,
equator, hold on, there's an angle to Polaris as you move away from Polaris, right? The whole elevation angle. That's how sundials work and everything. How you set up a sundial. You set the gnomon to the Polaris. So you can take those angles as you keep getting further away. When you get all the way to the equator and Polaris is starting to intersect with the ground, you're not at the same elevation as Polaris.
Yeah. Are you above Polaris, Jeremy? Are you
And
above
that's
Polaris now?
if
right. If
everything's
you
in
went
its
if you went up on a 5,000 foot mountain at the equator and you're seeing Polaris, setting at you're not 5,000 feet above Polaris. You're just making a faulty link there, claiming that that's quote unquote geometry. But that's not how the celestial sphere works with perspective and elevation
so
angles.
Geo, if it's not geometry and we're not seeing Polaris in its true actual position, that's fine. The celestial theodolite. Can I just get Beast to answer my question?
No, because the negative thing is not an issue. Because if you take an elevation angle to Polaris at 30 degrees, that's still 30 degrees latitude. Just because you can be at a 5,000 foot mountain at the equator and see it setting at the horizon and think you're not 5,000 feet above it, and at the same time the elevation angle still correlates at 30 degrees north, which is what they're doing with the celestial theodolite idea, is the star with the mountain.
Dude, if you say you're doing geometry, and you make a horizontal line and everything's in its actual true geometric position, shit below the horizontal line is below it. You're below it. Geometrically, physically, you would be above that thing. This is not hard, guys. I don't know why this is a problem. That's how geometry works. Yes.
No, it does not. Not in the distance like that. Does not work that way. You're not above it.
Geo, we already went through your plane scenario. You're saying it's not in its actual geometric position. That's fine. If you were saying it was in its true geometric actual position as we see it, we would be above it.
All right. Hold on. Wait. I got an idea. Jeremy, I got an idea. Okay. Let's use that plane scenario. Okay. 10,000 feet high. I'm on a mountain. I'm looking at another mountain that's 5,000 feet high. I see the plane intersect with that mountain. Now I have a negative angle. Okay. Now, at that same exact moment in time, could there be someone that could also take an angle to the plane when it's directly above them overhead?
Sure, but if you yes, they
can, right? It would be a 90-degree angle, right?
But if you're making a horizontal
hold on
line,
do you agree with that?
Yeah, I agree with that. But if you're making a horizontal line from the top of the mountain, and you're saying everything's in the true geometric position.
Listen, that's what we're comparing the angle to, okay? Because at a certain point in time, that star is going to be directly overhead according to the nautical almanac. Do you understand?
Guys, this is really fucking stupid, guys. If you're doing geometry and you make a straight line, if you're doing geometry and you make a straight line, things below that line are below it. This isn't
Oh
fucking
my
rocket
God,
science.
dude.
Dude. We're going in circles, dude. They're not.
That's
I
just
don't
not
know.
how it
It's
works.
really simple.
That's how
What
geometry
what you're
works.
calling
Gio,
it, what you're calling a true, what you're calling a true geometric position would just be an angle from where you are. But I feel like what you're trying to link that to is like a tangible elevation or a tangible altitude. Nobody's claiming you're
That's what
tangibly
geometry
altitude.
does.
You're not tangibly altitudinally above the object just because you're getting an angle to it. So
If
we're
you're
just
above
talking about
it
two different things.
geometrically, then they're claiming that you are by saying geometrically.
Oh my God! So you guys are literally just making a semantic argument. If
It's
you
not an
understand,
argument. You
semantic,
guys
it's
are doing that
geometry,
by
dude.
claiming
This ain't
using those
semantics.
words. If
This
I
isn't
say the Earth's a
semantics.
globe and you're saying, "Oh, it's semantics,"
all right, what?
you said the words.
It's not semantic beast, it's geometry. And it's simple. Things above your horizontal line are above it. Things below it are above it. If you're saying things aren't in their actual position, like Geo did with the plane, that's fine. There's some optical thing happening in between you and the thing that's making it appear where it not actually is. But if you're saying it is where I actually see it, then it's below you.
No, we just need to define terms. Because geometry can involve angles. It doesn't mean tangibly altitude just because you're getting those angles. So there's two different things.
The geometry of the line. Sorry.
Yeah, the geometry of the line of the optics. So if you're on the 10,000 foot mountain and
they're saying the position.
if you're on the 10,000 foot mountain and you're looking off to the 5,000 foot and the airplane intersects with that 5,000, there is a negative angle geometrically due to the optics, perspective, etc. But that doesn't mean altitude, like tangibly in physical reality, that you're above it. And that's what you're linking. You're linking the geometry angle due to the optics, etc., to the actual altitude physically. And then I think it seems like conflating those.
No,
Conflating
I'm not
true
conflating
geometry.
anything, dude. I'm not conflating anything. If you're doing geometry and you make a horizontal line, things below the horizontal line are below it. That's how geometry works. They're not saying there's some optical effect where things are appearing where they're not. They're saying everything's geometric.
Okay, so if you think so, like the Polaris from the equator, do you think the Polaris is actually below your feet if you move
No, I
away
don't
from the
think
equator?
Polaris is. No, because I'm not running around saying stars are in their actual position because I'm not stupid.
There, it is the parent position. Even when we say true geometric position, we're referring to the time. Okay, because there's a certain time that's linked to a zenith measurement. Do you understand that, Jeremy? Do you understand that?
Not their geometric position.
Oh my fucking God, dude.
Bro, it's really
Because the
simple.
thing
Just
is,
say
bro, like,
apparent.
all right,
There's no problem.
if you're on a 5,000 foot mountain on the equator watching Polaris, setting, you're claiming you're not above it, and then therefore you're saying, okay, things are not in their geometric position. However, if you go 30 degrees north and you pull out a sundial in your garden, you have to point the gnomon of the sundial at Polaris, and you better darn hope it's in this right position because that's how you're going to tell time with the sun, and it has to be accurate, and it is accurate.
Yeah, because
It's how you'll tell time correctly by pointing the gnomon at the 30 degrees or whatever it is at Polaris. So Polaris is not just at 74 degrees or 18 or all over the place. I mean, there might be a tiny bit of refraction and get into that, but I mean, it's right there, and that's what your latitude is, and that's how a sundial works, meaning the sun will accurately give you the correct time due to the fact that you set that gnomon up to Polaris and the way the sun circuits with Polaris in the north.
Yeah, because the apparent positions repeat, mathematically, but it's not.
Yes,
So
exactly.
that's accurate. That's accurate.
Exactly.
And you're still not above it when you're on a 5,000 foot mountain at the equator. And the 30 degrees and the 30 degrees in the north is accurate for a sundial. It is in its position.
Geo, like the plane, like you said with the plane. When you're on the ground, we drew a line to it with a fishing line. Once we got on top of the mountain, though, you couldn't draw a line to it with the fishing line anymore because we weren't seeing it where it actually was, right?
Oh, Jesus Christ.
Right,
Jeremy.
Gio?
Can you do me a favor, Jeremy? Can you read that paper I sent? I'm gonna send
Gio,
it to
right?
you.
Right, Gio?
If you actually want to, if you actually try to do this in good faith.
Please don't let him answer this because I know.
No, we've answered it like 15 fucking times, Jeremy.
Can I talk about my picture real quick?
Geometric, yeah. If you're using the word geometry, it is in its geometric angular position. Yes, it's not altitudinally. It's not altitude below you. It's not physically tangibly below you.
Are we seeing it where the plane, when we're on top of the mountain, are we seeing it where it actually is?
And
Yeah, it's actually there in reality. Yeah.
And that's the angle.
no,
That's the
not what
real
he's
angle.
asking.
We could draw a straight line from our eyeball to that plane. That's where it actually is.
Dude,
then
the
then you
airplane
would
is
be above the
actually
plane.
there
Then
in
you would be
reality,
above the
Jeremy.
plane.
That's not what he's asking. Can I talk about my picture
vision
real
is
quick?
not reality, bro. You see things in
It
apparent
might
Well,
clear up
positions.
everyone's
You're
misunderstanding.
doing geometry to apparent positions and calling it geometric positions, which is weird.
It's still
Yes, it's fucking
geometric.
crazy.
Geometry has
This
to
is
do with
crazy,
angles.
guys.
The geometry of the line to the angle that where of the apparent thing you see it is geometry, but calling it a geometric position where the star is at, that's claiming the globe model.
This
No,
is
it's
y'all's
not.
confusion
Yes,
with
it is.
apparent and
That's literally
geometric.
what you're doing.
Not that at all, because it has an angle to the ground. The celestial sphere has positions and angles to the ground, and that's what this shows: is the relationship of the geometry of the ground in relation to those objects in the celestial sphere, which are all in a particular GP position above the ground.
Which is apparent.
That's why this is very useful. This approach. There's a
I
bunch of
agree,
tests that
Gio.
can be done off of this as well. A bunch of
Yo,
additional
Beast, can I
tests.
ask? I was trying to ask you a question. Can we move on from this?
Hold on.
I mean,
wait,
Jeremy, I would
wait.
just say when you're on the mountain and you have the negative angle to the airplane, you are getting a negative geometric angle, but that doesn't mean that you're physically above altitude-wise above the airplane.
Okay, then the
That's
plane
the
wouldn't
difference.
be. Then the plane wouldn't be where we see the plane. It wouldn't actually. It couldn't actually be there because if it was actually there,
What the
then
fuck?
it would be below us if we made a horizontal line.
Jeremy,
Right,
what the
Gio?
fuck are you talking
Still
about?
don't let him
No.
answer this. Still don't let
No.
him
I know
answer
what
it.
he's talking about, but go ahead.
No,
The
you're
plane is actually there in reality, dude. I see a fucking plane
I don't
flying.
even remember
It's
what I
in
asked at
it's
this
there in
point. You guys are
reality.
a mess. You guys are a mess.
If you
Jeremy-
see that negative angle, that does not mean that you're at a higher altitude physically than the airplane. It means that due to the optics and due to the way perspective and the entire way that things set in the distance, that the angle could have a negative angle, but
Okay, so
that
then we're
doesn't
not
mean that
seeing
your
it.
altitude. You are
Gio.
seeing it in its position due to the angle of your optics at something in the distance, but it doesn't mean it's a higher altitude or you're a higher altitude.
If I see something in its true actual geometric position and it is beneath a horizontal, it is below you. That is a fact.
That's retarded, Jeremy.
That is a fucking fact of geometry.
Can we
That's just not the case, dude. Just like when things look like
That's
they're ramping up.
Gio, that's geometry. Yo, I'm not even high as fuck right now. How are you?
Jeremy,
What is
just-
wrong with
I
you
don't-
guys?
I'll smoke
Yeah,
you.
I
Dude,
don't
just
know.
like
Can
when
we
things
just-
ramp up, just like when the ground ramps up, it's not actually raising in altitude. Geometrically, the angle looks like it's ramping up over a planar surface. That doesn't mean it's just a different scenario, but that doesn't mean that the ground is raising in altitude. Ground
we
could be
don't
the same
think that.
altitude.
We don't think that.
So
but when you
optics-
guys-
I'm loading a joint. Fuck this.
No,
Bro, I
Gio
don't
is
know.
correct. In FE via that model, things ramping up are not due to anything ramping up. It's due to perspective.
Thank
Yeah, and
you.
I'm just making that link to say that when things are ramping down, it doesn't necessarily mean that they're at a lower altitude. So I'm just
Yeah,
saying when the ground looks like it ramps up, I'm on the highway right now. It totally looks like the ground's ramping up, but it's
Yeah,
not.
and if you claimed that you know,
It goes the
everything
other
is
way
in
too.
geometric position, then we're not talking about perspective anymore.
So Jeremy,
Geometry is not tangible. Just okay. That's what I think we would need to do is define terms. You guys are saying true geometric
read the
position. Do you mean
geometric position.
tangible? The tangible position? Because
Well, I mean,
the
no,
geometric
It's
angle
called
is different
geometric
than the
position. I
tangible.
looked it up. I read it.
Yeah, let's ask Jeremy that.
Geometric position means where you see it, that's where it is.
right, because in FE, the ground appears to rise up. So when you point to something, you're pointing to something appearing to rise up. You're not pointing at the ground technically.
Geometric position. That means if I were to make if I see something in the distance and you say, "Oh, that's at its actual true geometric position." Then and I make a horizontal line and that thing's below me and that thing's below the horizontal line, it's below you. It's below that your eye level or wherever your eye is on that horizontal line. This isn't fucking dude, this is simple. How are you guys not getting this?
This is what the globe claims.
Not
The
how it
globers
works.
claim everything's in its
That's how
geometric
geometry
position.
works. That's how things would
plus or
work
minus
if you
refraction.
Geo, if we have something in your backyard, let's say there's a picnic table in your backyard, and we set up a theodolite, and the picnic table's 4 feet high, and we have a theodolite that's 5 feet high, and you say, yo, everything's in its geometric position, and we take the theodolite and we look through it, and the picnic table is below that horizontal line. That means the picnic table is below your eyeball, right?
It can't. Yeah, this is what I was saying before. There's two things going on here. Something can drop in the distance due to actual tangible altitude drop, or things can drop in the distance due to the distance you are away from it, essentially. So there's two reasons things drop. One of them, tangibly altitude, the thing is actually lowering in altitude. It's getting closer to the ground. The other way is that you're getting further away from it, which I would use, like if you use the term perspective or, etc., you could use those terms.
There's one more.
So that's the difference. So the one you're saying is yeah, physically lowering in altitude. Yes, that would be the case. And if you could measure an angle that's below zero, so you're not totally wrong in what you're saying. You could measure an angle that's below zero, that of something that altitudinally is actually below you in altitude. Or you could measure something that's below you due to the actual angle as you're moving a very far distance from it, which we call setting, like when things set. So there's two different ones. One of them, you're correct, you would be altitude higher than it. The other one you would not be, and the negative angle would be due to the actual perspective and the fact that that object is moving away from you at a very far distance, and you have that factor involved.
Jeremy, can you tap out? Someone's got to.
No,
Yeah, he can't be serious at this point. This is like day one rebuttal to Glovers for sunsets.
No, Jeremy.
It looks like the sun's converging with the water. You're 6 feet above the water. Are you above the sun, Jeremy? No, you're fucking not.
Wait,
Bro,
Geo listed
my
two
God,
examples.
dude. How is this going on?
Hold
dude?
on,
This
Q
is
up. Hold on.
crazy.
Jeremy listed two examples. Geo listed two examples. Jeremy is aware of a third one called refraction, which will make things appear lower and higher than it actually is. This has not been considered in the conversation yet. Jeremy knows this inherently. When he asks you about like the airplane and is the airplane actually there or not, that's another possibility, and that's not being incorporated. The Glover model has refraction always.
All right,
So this is a big
spiraling,
deal
bro.
to take into consideration.
Can we just drop this?
Well, let me respond to him, dude. Hold on. Let me just respond. I hear you, and I'm fine to agree with that at the moment, that you can also have refraction just for the moment that could loom or sink things, looming and sinking. So that's fine if you want to talk about that third one. But Jeremy, I feel like what I just said should have solved it. Did a light bulb go off or no? Do we got any light bulb? Can Jeremy at least respond to that? If you guys want to go on to other
I don't
stuff.
know. What did you say again? They went on a whole tangent there. What did you say?
I said there's two reasons that things could drop in the distance and become a negative angle. One of them is the actual altitude of the thing is dropping, which, like you said, if you're in your backyard with a picnic bench and you set up a theodolite, and if something is, one way to get a negative angle is that the thing is actually physically lower than you. And I agree with that. That's a thing you can do. Like if it is actually the altitude of it, someone was laughing in chat that I was using the word altitudinally that I made up. If the actual altitude is actually lower, you can get a negative angle. However, there's a second scenario in which you could get a negative angle. That is when there's an object that's not lowering in altitude, like in the sky above a planar Earth. It's not actually lowering in altitude, but it's getting very, very far away from you, further and further and further and further. So it's dropping due to that incredible distance between you and that object. It's not dropping due to actual altitude. So those are the two things.
Okay,
so that you're trying to link the one. You're trying to
address it before I lose it, bro.
Right.
Let me address it.
Go ahead. I know. I tend to go on.
You can get farther away from things, and they will lower. What they will never do due to geometry or perspective is they will never cross that horizontal line. Something above your horizontal won't go below it due to perspective or geometry. And if you're saying perspective doesn't work,
it will
like
if you're on mountains.
No, it never. It
will
never
if you
does.
have something being occluded. Yes, it will, because the mountain's above the ground, and you can't see for infinite. But sorry,
if things are in their geometric positions, and as you get away from them, you back up far, far away. If it's above your horizontal, it does not cross the horizontal line. If it's all geometry, it'll never cross that horizontal line.
Yeah, but because of optics, Jeremy, and things getting further away in the distance, it would appear that it would drop below your horizontal. This is like basic argument 101.
Apparent geometric positions are 4.
Dude, if you're claiming you're doing geometry, and everything's in their geometric position, things that start above your horizontal do not cross
Okay,
below your
all right.
horizontal, no matter
Hold on.
how far away you get from them,
Let me
as long
pause
as you
you.
just stay at the same altitude.
I want to be clear. When you are saying, we are saying everything is in its geometric position. Do you know what we mean by that with the celestial theodolite specifically?
Unless you mean something different than what geometric position means, then I don't know.
Okay, well, I've already defined it for you like 5 times, so I'll do it a
All right, why
6th
don't you
time.
say it again? Go ahead.
Okay. So when we say true geometric position of the star versus its apparent position, the true geometric position refers to where that star is at that time, where its zenith would be in relation to where you are. And that's according to the zenith measurements taken to that star with the nautical almanac, okay? Because at a certain position, that star is going to be directly overhead at one point, depending on where you are, right? You're going to get its GP. So we're comparing that GP, right? That true geometric position versus what its apparent position is when we observe it getting occluded by the mountain. That's it. It's very simple.
Okay, so things aren't where we actually see them then. The star or the mountain, they're not actually where we see them.
Nothing's real, Jeremy.
Yeah, like I
Is that
don't
what you're
understand.
saying, Beast? Is that what you're saying? They're not where we actually see them?
The mountain's there, dude.
Is it where
I
we
can
actually
physically.
see it? I know
Hold
shit,
on,
the
hold on.
mountain's there.
Okay,
Dude,
I
what a
can
fucking
physically.
stupid game are you playing?
Dude, what stupid game are you playing? All right, I can
I asked you a
physically.
simple
Hold on.
question, you won't
I'm gonna
answer it.
answer it. Hold on.
Why
I can
didn't you just answer it in the first
Are you
place?
gonna keep
Let's just-
interrupting me, or are you gonna let me answer it,
Yeah.
dude?
We got to keep cool heads to a degree and just not take it personal. Even if we disagree, let's just keep with the info.
Okay.
It's all good. Good.
Jeremy, can I physically go to that mountain peak?
You're not answering my question. You asked me another fucking question. I'm done playing your stupid game, Beast. I'm
Okay.
done.
Well, I guess he's
I don't
done.
think he's-
Yeah, because you're playing a stupid fucking
Yeah.
game. This is the type
Yeah,
of
It's
shit
not.
fucking.
No, it's not a stupid game. Everyone knows in reality you can go to that mountain peak, okay? You can physically go there. Can you physically go to the star? No, Jeremy. So you're making
Yeah, so
apples
don't
and
claim
oranges
it,
claims.
and then don't claim you know the geometric position of it,
Ask it again. Are
Yeah,
things in the
especially if it's fucking
my actual
dropping below.
response to what Jeremy is saying actually is that if you're trying to line up a star in the sky with a mountain, there could be a straight line between you and that star, in reality. But if you then go to a 10,000 foot mountain and then you're looking down at a 5,000 foot mountain far from you, and then you see a star occluding, that is not that is not creating a line in which you're above the altitude of it. So I guess the answer to what you were saying, I guess, is no. The negative angle is not giving you a clear geometric triangle because you're going negative, whereas the other one is. Like, that's why I was saying, like, if you took a sundial from 30 degrees north and you point it to Polaris, it's going to be 30 degrees because the sundial is going to work. You're going to get accurate time, the angles of the sun. And, if you go to 31, it's going to work. 35, 36, 37, 38 degrees. That's all good. That is in its geometric position above the ground in relation to the GP in order to get an accurate sundial. However, in the same moment, if you go, or in the same kind of vein, if you go to a mountain at the equator that's 5,000 feet altitude and you see Polaris setting at the horizon, you are not 5,000 feet above Polaris. So both are true. The 30-degree angle of the sundial at 30 degrees north, the angle to the sundial, that is in a position, geometric, right angle, all that you need to make a sundial. And at the same time, if you're, at the equator, 5,000 foot high, and you see Polaris setting, you are not geometrically above Polaris. Both of those things are the case and can both exist.
I think I have a way to fix this. So when the stars
Wait,
are
does he
like
have a response to that? All right, if you want to go. Does he get what I mean, though?
Yeah, so we're not seeing. So when we're on top of the mountain and we see Polaris below us, we're not seeing Polaris in its actual position.
You are seeing it geometrically in a negative angle, but you're not seeing it in a way in which the altitude is related to your altitude because you're going negative and it inverts the whole thing.
So we're not seeing Polaris, and we're not going to take a fishing line and make a straight line to Polaris because right?
Yeah, the altitude angle The altitude of angle of Polaris becomes irrelevant if you're at a 5,000 foot mountain and it's negative. It's not relevant to a right angle triangle to the
Because you're
ground.
not seeing it in its actual position. Because if you were seeing it in its actual position, it would be below you.
You're seeing it in its angular position due to the perspective of how if you're
Not
distant.
actual.
You're still seeing it.
You're not seeing it where it actually is, though. Because if it was actually there, it would be below you.
So you're claiming you're on top of the star now, Jeremy.
Nope. The celestial theodolite people are claiming we're on top of a star. Welcome to the convo.
No, we're not, dude. Fucking
Yes,
don't
you
straw
are.
man
Just
it, dude.
hear, just
I'm not
hear him
straw
out.
manning you. That's a steel man of your fucking method.
Yeah, it is. So yo,
It's not,
P,
dude.
So
It's not. I just
It's a
described the difference.
It's a complete straw man, Jeremy. And I don't know why the fuck you're doing it. It's kind of gay.
you
But
guys are
I
using
honestly
the
feel
wrong
like the
words.
room feels the same way that Jeremy does. You guys are saying curved visual space, and then you say it's in its geometric position. It's double speak.
And then
It's
yeah,
ridiculous.
and
I
we
think
haven't
maybe they're
established
trolling
yet
us, bro.
if there is refraction or not, which will change everything. We haven't established this yet.
That's a different
All right,
topic again.
It's
gotta run-
all
hold on,
one
you got-
topic.
I got to run into the store, so I'm going to be on mute for a while, and I'll just be listening, and I won't be able to talk because I don't like talking in stores. So I'm going to be cringing if I want to talk, but I can't. Just give me my last like 20 seconds. I'm going in the store, so just give me my last 20 seconds here. I mean, Jeremy, you and I could talk about this more later, but I thought what I said laid it out pretty well, dude. If you're at 30, I'm just one more time. If you're 30 degrees north, you take your sundial angle. That is accurate. 30 is accurate. 31, 32. Therefore, you are seeing Polaris, quote unquote, in its actual position. I mean, it's still apparent because you can't get to Polaris and touch it. But I'm just saying it's in its true, apparent, etc., geometric 30 degrees, 31, 32, 33, because like in terms of a sundial. So that is all good. But I know I'm repeating myself, but when you go to the equator and you're 5,000 feet tall and you're looking at Polaris on the horizon, that's called a dip angle. It actually gets back to what a dip angle is in celestial navigation. So but just because you have that dip angle does not mean that you are physically above Polaris. If you're, even though the 30 degrees north is accurate. So that to me, I know I'm repeating, but that's like the relationship. What they're doing with the celestial theodolite, that's like the sundial at 30 degrees north. You get an angle, whatever. Now they're linking it with a mountain instead of just to Polaris, but that's that version. And it is accurate to the GP, the angles of the ground, all that will line up. All that's the case. And then hold on. And then the going to the equator with the Polaris thing, that's like the airplane with the 5,000, 10,000 foot mountain to where you're seeing a negative angle of it. So the first one was true, and the second one, the angle's negative, and the second one does not mean that your altitude above it because the object has moved further away distance and it's setting, and so the dropping effect is due to the distance you're getting from it, not the actual thing dropping in altitude. All that being the case, the celestial theodolite would be like your angle to Polaris to make a sundial, and that's still valid, and you can get valid information of the angles to that to the ground in terms of what the shape of the ground is.
And I know how to fix this, Jeremy. Can I go?
Well, I'm done, but can we at least give him the mic time to at least respond if he wants to? I feel like that should be lighting up a light bulb in his brain. If it's not, fair enough, and I'll just but I'm going on mute. But just give him a chance to respond if he wants. If not, then yeah. Radio silence. All right, maybe
Jeremy,
he's.
I know how to.
You can't.
I know
Maybe
how to finish this fucking ridiculous
Go
game
ahead,
we're playing.
queue up.
All right. I needed a glober. I need a Matthew. Can you answer a question for me?
Maybe.
Yo, so I'm on a mountain, right? It's a 5 mile high mountain. I'm looking down at the horizon, and there's like stars like setting, right? At night or whatever.
Okay.
Okay. So in the globe, like you believe like those stars that are setting are they're in their geometric position below me, right?
When you get below 20 degrees angle of elevation, things start diverging from their actual location due to refraction. That's why I don't use those stars for navigation.
Okay, but let's make the mountain
close, yeah.
30 miles high, and these stars are setting.
Okay, if it's 30 miles
You draw
high,
a straight line to them, right?
Yes.
And you believe they're in their geometric position, and they're actually below you, right?
Yes.
Okay, so you guys are doing what he's doing, except he believes it, and you guys are flat earthers, and this is fucking annoying.
Well, give us your stance. And
just say apparent position, and then no one will argue. Because when you say geometric, you're claiming the globe model, which is what I said to begin with, and he just proved it because that's how they speak.
No, globe model is apparent. We see an apparent in a globe model.
Slight apparent, but it's closer to geometric than
we
the flat earth.
Take the globe model in a vacuum. Okay, now we see geometric. Now put in any kind of medium like air, which bends the light. Now we see apparent. What that means is what to me apparent is just you see it, but doesn't necessarily mean that's what's happening.
Okay, but on the globe model, it's way closer to geometric.
I have a picture I want to talk about. That'll help you out with this.
I don't need help. I think that settled it. Yo, B. So what's with the fudge factor? What is that based on?
The fudge factor
it's not really a fudge factor; it's a timing correction.
Yeah, what is the correction based on?
That Dr. Mike, it's based off of Dr. Mike basically taking a ruler to his monitor and measuring the difference in azimuth to get the timing difference, and then applying that timing difference to stellarium as like a manual correction. He does it for all three, right? So like if you do it to one, and you're doing it to all three prediction or calculations.
Can you reword that?
What do you mean?
It's
not a fudge factor. It's a timing correct. So you have one graph, right? And you have basically these large deviations on all three prediction or all three calculations, right? And what he's doing is making it more accurate to the zero line, the deviation from like 0 degrees deviation. So it's adjusting all three lines of the graph to basically be as accurate as possible to the measurement that was taken, which was the timing measurement.
Does he do that?
So what he actually saw, like that actual timing and that actual azimuth, you get what I mean? The actual angle, like what he saw, that timing, that's what he's comparing the difference in azimuth. So like when you move the observer, right? When you move this observer in stellarium to the mountain peak, it doesn't account for the azimuth change. So he basically just figured out like, that's why I'm getting these weird deviations from 0. He basically just made it more accurate in terms of matching up to what the as close as you can from 0 deviation to basically show the differences between all three. But sorry, dude, I'm super baked right now. I can't really explain things right now.
But so now does he do that every time measuring with a ruler, or does he just assume the fudge factor?
Here's the it's not a fudge factor, but here's the problem with it, right? Like to recreate the J value, everyone could have a different monitor, a different pixel count. Like the method is not easily, it's not easily done for every, like you'd have to figure out the math behind it. So, I mean, even without the fudge factor, you could still see what's closer to the 0 line, like the deviations, right? But he just did it to make it more, like, as accurate as possible. But the problem is, if you were going to do it, like, on your own observations, right, you'd probably have, like, a different azimuth correction as well. But he's only doing it because he has so many data points. Right, so he's just basically trying to see where that deviation is coming from in stellarium because it's a stellarium error. That's
what is he measuring with the ruler exactly? But like between what two things?
The differences in azimuth, basically. So azimuth is like your direction, right? So if you have 360 degrees in a circle around you, your azimuth is like which direction? Like in the entire 360 degrees.
Okay, but he's measuring like the azimuth, the two different azimuths from what?
Yeah, it's an error that he's noticing that stellarium is doing when he moves the observer to the mountain peak at that time. It's not accounting for the azimuth change or something like that. And he figured out how to basically make the data more accurate. And it's fair because he's applying it to all three. It's just to make the graphs look like you can definitely see the differences in predictions essentially. It's totally fair to do. It's no one can recreate it because everyone has like a different monitor size, pixel count, etc. Like it's just off by either like 4 or 5 arc seconds. Like Piezo was trying to recreate it. A lot of stuff. But
yeah, I still don't get it.
That's okay. It's fine. I don't feel like explaining the J value right now.
Let me ask my question. I've been waiting a very long time, please.
All right, you're gonna keep waiting because I gotta go.
Yeah, you're running for me. That's fine. I guess.
No, I have to go.
Yeah, that's convenient.
No, I'm just kidding. I'm kidding. I don't have to go.
I knew it. All right. If you do want to go, you don't have to do this with me. But
No, I don't have to go. No, I'm just fucking with you.
All
You
right.
just said I was waiting for a long time, so I was just kidding.
I certainly was. So the dude's brother brought a theodolite to his house, measured the elevation angle to the mountain. It was 2 degrees and 19 minutes. It doesn't match the flat Earth trigonometry. So you're saying that there's curved visual space. That's why it's being displaced vertically. It's appearing lower than it's. When you say actual, I feel like you're conflating the word actual. You got what you see in reality, and you're saying what you see in reality is not its true position due to curved visual space, right?
Yeah.
You following?
Yeah. I think
Okay,
that
so the
things that
flat Earth trigonometry prediction, 2 degrees and 31 minutes, is not what you observe, right?
no, he
That's not
observed
what we
that.
see in reality. That's not what you measure. That's just a
he observed-
trigonometric prediction.
Hold on. He observed that with his level transit with the David Weiss 8300
So what? Dude's brother came through with a real theodolite
with
and
another
measured the angle.
theodolite, right?
Yeah, the angle with the theodolite was 2 degrees and 19 minutes, correct?
Yeah, he thinks there's a
It
scaling
matched
error
Earth.
with. So let me find. I'm gonna find the old spreadsheet. So he thought there was a
did the
scaling.
angle measurement with the theodolite.
Bro,
match
I'm
Earth?
trying to answer you. Jesus Christ. Trying to do this gotcha. I'm trying to answer your question. All right, so he says that there's a scaling error, right? Based on the distance. So the distance he was away from the mountain peak, right? It was like 50.7 kilometers away. He calculated this error, right? The scaling error, basically, which was drop over distance. It basically equated to 8 inches per mile squared. In the theodolite, he says that like if you move it, what was it, 6.3 kilometers, or I can't remember the exact scaling error. I have to find the spreadsheet, but no, yeah, when he got that measurement, right, with the theodolite, he was saying that he thinks that the older models, like the level transit, like the David Weiss 8300, didn't have that scaling error in it. I don't know, with the lens. Dude, I'm way too baked right now to talk about all this. I'm sorry. I just took one to the dome.
My understanding is you guys are claiming there's a straight line from the observer to the peak of the mountain to the star, right? You're using flat Earth trig, no refraction. If that's its actual position, and in reality, what we see is the 2 degrees 19 minutes, then it doesn't match the flat Earth trig, right? Therefore, when you say that, it's a flat Earth and it literally looks like it's dropping over distance, and you invoke curved visual space, so it's not in its geometric position. You can't have both. It's like wanting your cake and eating it too. And this is Jeremy's point. Jeremy's saying, like, I feel like we're conflating the word actual. What you see in reality and where it appears, and where it is in reality, the two different positions according to this curved visual space model.
Can I make a quick interruption for an announcement? Anybody who's in Southern California or Arizona, you should set your alarm for 8:51. If you look in the side chat, there's another launch scheduled at just the perfect time after sunset that it will probably light up the whole sky. So if you've never seen a SpaceX launch and you live in Tucson or Phoenix or San Diego or Los Angeles or Vegas,
What about Las
or
Vegas?
near, yeah, it's visible in Vegas too. It's a little bit lower on the horizon to the west, but if you go outside, do you see what level is posted? That's a time lapse of what it looks like.
I thought you guys had enough fireworks over there after Freedom Day or whatever you call it.
That's so convenient. No, my point's not going to get addressed. That sucks. We're
Oh,
going
go
to
ahead.
talk about that.
I was just
dude,
announcing it because it's timely and it's happening about.
I really don't care.
Jesse,
It'll
I'm way.
always be confusing. I'll never understand your confidence. That's right.
I'm just way too baked to argue.
No,
right
we're
now,
going
dude.
back to
I still
the
got it, dude. I still got it in the talk. I can bring it up later.
Okay, I got you though. I'm literally just way too baked to even care. But I get what you're saying. I get what you're saying. The thing is, it's like you got two different interpretations of optical like angle measurements, right? you could claim, like, if you're shooting a theodolite to a mountain peak that's like 75 kilometers away or whatever, like, or 75 miles away, like Jesse did, and then you basically claim, oh wow, it's following the curved path, like it basically looks like Earth curve, right? But it could also be the light curving. Like, how can you differentiate between what is refraction and then what is Earth curve? How would you actually differentiate that?
Yeah, I've been
I
bringing that up a lot lately. Yeah, it is
Right.
refracted. It is refracted further from the globe prediction than the flat Earth prediction. I definitely noticed that.
I'm just saying that you got two different, like, you have two different interpretations, and then where's the differentiating line between the two? Right? Like, do
But
boats
the whole
disappear bottom up because of, just optical convergence? Or is it because of Earth curve? Or is it both?
the whole issue is the claim
How
about
can
the
you do?
straight line to the star, and then you want to move the observer to the mountain and consider that elevation angle to the star is going to be the same because you're just like your curved visual space. Your curved visual space. You want to invoke it in the first instance, but not the second, because you admit that it's not at 2 degrees and 31 minutes, right? It's being lowered. But when you bring the observer to the mountain, you say, "Oh, look, with the regular flat Earth trig, it's 2 degrees 31 minutes again." But now you
And
don't have curved visual space.
isn't that an interesting coincidence, though?
But you're no longer applying your
Hold on.
curved visual space.
Isn't that an interesting coincidence, though? That when you do that in Stellarium, you basically just get plain trig. So, I mean, in essence, what Dr. Mike is really doing is exposing Stellarium's bias. That's what he's doing. Like the
If
69.
anybody actually heard what I said, salute to y'all, man. I'm done.
Okay.
And it sounds like you got some good ass weed, bro.
Dude, I really just took one to the top. I got way too baked. Yeah, celestial theodolite. It's an interesting concept. The whole thing is fascinating to me because it's like, from what I've seen, it basically is making the stars almost coplanar.
The flat Earth
Look on-
trigonometry angle to the star from the peak, from Pike's Peak, it cannot be 2 degrees and 31 minutes. The flat Earth trig angle would have to be different. You're getting closer to the star. You're getting closer to the GP of the star. That would put the star at a different elevation angle. You guys are saying that it's the same elevation angle from his house and the mountain. So, like, you say that there's curved visual space
Yeah, so
happening, and it's
the
at 2 degrees
parent,
and 19 minutes from his house. Okay, go ahead.
you know what the parent angle would be? 2 degrees 46 arc minutes.
That's with
Right?
no
What he's
refraction.
figuring out is this relationship, and this is what I mean by true geometric position of the star, is when the star is actually at its zenith, where its GP would be. It's basically, it's based off of the timing, right? So, like, that star would be at that zenith at that time, right? But according to him, where he was at that location, where the peak was, right, it would be 2 degrees 31 arc minutes. And it just so happens that it matches the plane trig that you would calculate with the elevation, just arctan over rise over run. Like,
He's getting closer to the target. You're taking an elevation angle to your target from his house. It's 2 degrees 31
I know
minutes. Now he
that
moves
is
to the mountain. That would change the elevation angle.
the apparent. If I was going to take a theodolite, like, at the top of the mountain and actually look at the star, that, who knows? Who knows what would we get?
I said I
I
was
think
done.
you
I'm
would get
sorry,
it.
bro. I keep
You did
going.
say you were
even though I said
done.
I'm done.
I'm trying to answer. Like, I still think it's a fascinating thing, though, that if you take occlusion timings, right, when the star disappears behind the mountain, so basically you're using the mountain as crosshairs, right? And then plugging those coordinates of the peak at that time, putting the observer there, and then taking off atmosphere like celestial refraction, it matches a plane trig angle, which is interesting. Isn't that just a weird coincidence?
That can't be the case for any time you try to measure an angle to a star as it's occluding a mountain. It would have to change depending on the distance to the mountain. That occlusion angle is not going to match the flat Earth trigonometric angle every time. If you move the mountain, you're not going to get the same thing.
I don't know what to tell you though. I don't know.
I mean, I'm sorry. Maybe I just finally got it all out. Sorry if it's overcharged.
You're good. As Levelist keeps saying, Mercury's in retrograde. He's like, I can't believe it's a fucking thing. Everyone is arguing like it.
Electric, I'm streaming on
so
Switch
much.
real fast, so if you need to go,
Ooh, shit, let's go.
check me out. Sorry, guys. Go ahead.
All right, so you said 8:51, Matthew. I'm actually gonna look outside. I got a clear view.
How are you in? Well, don't dox yourself, but are you in
I'm in
somewhere
Vegas.
near Southern California? Oh, Vegas. Okay, that's right. You just said that. Yeah, if you have a clear view towards LA, then you should see it. I'm going to guess. So look at the link that I posted, and you can watch the live stream of the launch. And when it's about T plus 2 minutes or 3 minutes, you should be able to see it. And in fact, if you look on Twitter, I'll see if I can find one. There have been people from Vegas who have pictures of this.
Yeah, I'm gonna set my clock to it.
Well, yeah, there's nothing. Usually, nothing up there. Usually, there's no water vapor. But when a rocket goes by, it puts water vapor in the sky, so it makes clouds basically.
What do you think, Electric?
Yeah, I think Elon Musk is a scam artist, and he's not telling everybody that that's actually due to the atmosphere. I mean, he said it's water vapor. I don't know what that means.
Well, whatever it is, it's real because people could, thousands of people can see it every time.
You just gave this whole elaborate explanation. What do you mean, whatever it is? Like you were standing on business, you're saying that's what it was, and now you're like, well, whatever.
I'm saying that it's water vapor, but even if you don't believe that, you at least have to admit that it's something real because
It's
you
something.
can see it with your own eyes.
Yeah. We don't think. Oh, I don't think that the vacuum of space is above us or whatever.
Matthew, have you ever heard of superfluid vacuum theory?
I think I've seen some videos about it, but I don't remember the details.
Yeah, but Matthew, is the launch in its real geometric position at its real altitude?
Yes, and the Earth is curved. That's why we can't see it for the first 2 minutes.
See,
Okay,
you guys are using
kerosene and
globe
liquid
terms.
oxygen.
Now, the thing is, Q-Op, they used the stars to create the globe model.
Yeah, I agree. And
Taking it
we,
back.
we believe they're in their apparent positions. They think they're in their geometric positions. I'm so glad
Yeah,
me
but
and
they
Jeremy got
also-
to teach you guys these basic terms.
You mean apparent
Yeah, but to
position, meaning apparent position as where they appear to be when you look at them. Yeah, I'll agree with that.
But Matthew and I already talked about this, and
NASA still agrees
when
with
they
us.
do angles
Yeah,
to
me too.
stars, they treat the star as an infinite distance away, dude.
Yeah,
That's
in their
correct, too.
geometric
That's correct.
position.
See?
Yeah, but when you say apparent, you mean where they appear to be, and that's true. I agree with you. They're where they appear to be.
Aha! You can still take an angle to an apparent position.
Yeah,
Yeah, and it's called an apparent
right.
position. Yeah, good. Not a geometric position.
where they
So
appear to
glad
be.
we
Yeah, that's
agreed
not
with-
where it actually is in 3D space, right?
What do you mean that's not where it is in 3D space?
It's a light in the sky. All right,
Yeah,
guys.
it's a light in the sky. You're taking an angle to it. Yeah, you know where it is. You know where its ground position is.
Light in the sky.
All right, I'm gonna go
Beautiful.
outside and get set up so I can watch this thing. I'll see you guys.
that
Maybe
happening
I'll come
tonight?
back in here afterwards. and
Wait,
show
you
some
should
pictures.
stream it.
Are they launching one?
Hey
tonight?
Matthew, did Did you see what SE put in the chat? How there's like these new supersonic missiles that mimic the same exact like air submarine shit, like the SpaceX. Did you watch it?
Yeah, it looks
I'm
really
gonna go.
fucking
Yeah, I'm gonna go
similar.
watch this. We watched. I called up my dad, who's in Arizona, and we watched it together, so he could see it in Arizona while I was seeing it here in California, which is kind of cool. I live in the LA County.
Matthew's about to have a religious experience, guys.
He's not. He's just
Why
expands
the
right now.
religious
Good for you, man.
experience?
That's
Why
fine.
religious?
I'm just enjoying something in the sky. Why are you gonna make it weird?
Let me talk a little shit, man.
Okay, fine, sure enough. It's Friday night, whatever.
Yeah, you guys don't make it weird. He's just going outside in his boxers. No one's home. He's gonna
No,
drink
making it
some
weird.
lotion out with him. Look at this.
No, I appreciate it.
Thing.
No,
CQ out the
enthusiasm.
CQ out the Globers have to say that the stars are in their real position and they're light years away to make the Earth a globe. That's where they roll with it.
Yeah.
That's what they do.
You have to be
Yeah,
light
but
years
the
away, but that'd
distance,
be
the
Light
distance
years
to it
makes
doesn't
Earth
mean
globe.
it's still.
Wouldn't it be nice to take back the stars, Q up?
How you do that?
See,
NASA
I'm
shows
telling you,
nothing.
Q up. What the celestial theodolite thing, I think, has interesting potential, bro. I think there's gonna be a lot more to do with using the stars.
Yeah, we've used the stars for hundreds of years in celestial navigation. Yeah, the Earth's a sphere.
Nah, dude.
A celestial theodolite. Yeah, there's a lot of issues with
Yeah,
that.
yeah, because the real a fictitious observer at the center of the Earth is okay. That's real.
In the meantime, though, you're using using stellarium, which is a globe product, and using the distance to the peak using Haber-Sign formula, which is a globe product. So, I mean, tell me why this proves the flat Earth.
Stellarium is not a
I
globe.
don't think you get it, dude.
Stellarium is a globe product.
Flow to the punch. I don't
Stellarium
think you
uses the
understand
globe.
anything.
But it does not. It uses the celestial sphere. So you can turn on the azimuthal grid or the equatorial grid on the Stellarium. Those are like the two main settings. And the equatorial. Wait, is that mine? Sorry, hold on.
If you look at the code in Stellarium, it uses.
Sorry, hold on. I just had some. Hold on, my bad. My radio turned on in my car. There, okay.
Geo's being plagued by CarPlay.
Somebody's watching.
Yo, NASA Shield, can you steel man the celestial theodolite?
No, actually, I can't.
That's a great
Yeah.
question. Oh, look, he's in there. You got him. But he knows it doesn't debunk the globe, but he can't steel man it.
No, I can't steel man it because it's too. I can't steel man the flat Earth. It's too.
We agree with that too. I agree with the last two things you've said, NASA Shield.
What is the celestial theodolite? Do you know what it is?
Electric. Don't do it with NASA. Don't do it with him, bro.
Yeah, you're watching.
I'm curious if
you're
you
watching
knows
a
what
star.
it is.
You're watching a star set behind the mountain at like 2 degrees above the horizon.
See, he's almost there.
Yeah,
Dude, I'm
You're
sorry,
saying
you
wait.
guys. I figured out something was playing. A video was playing through Discord. All right, I think I'm back. I'm sorry. I think I must have clicked Shane's video and it was blasting through my speakers. Sorry. Were you guys on to something else or what?
No, go ahead. Go ahead. You wanted to say something for the radio.
I know.
pop
Sorry,
up.
I was in the middle of saying what I was saying, and then that started playing, and then it took me like 5 minutes to figure it out. So, what was? Now I forget the. Sorry, something NASA.
See, the thing about this, one of the problems with the celestial theodolite is you're so low to the horizon. When you're doing celestial navigation, you rarely use something that's 15 to 20 degrees below the horizon or above the horizon, and you're like 2 degrees above the horizon.
Electric, did I have sound on my stream?
I can hear your game. I don't know if you're talking though.
Okay, that's all I wanted. Just as long as you could hear the game.
Oh, I know what I was saying. On Stellarium, when you have the equatorial grid or the azimuthal grid, that's what I was saying. There's like two settings right on Stellarium. Right at the bottom, there's two icons. And if you click the azimuthal grid, it creates the ground as an azimuth, which is like a circle around you, a flat circle, essentially, planar circle. And then you have the hemispherical dome of stars around you, which is essentially like a planetarium, for example, will use an azimuthal grid. when you set up a planetarium, they treat the ground as a flat grid, planar grid, and then you have the hemisphere of stars. However, on Stellarium, you can also turn on. All right, if I was going to be a little rude, I would say turn on fantasy mode, but okay, I won't say that, but I'll say it to be funny. You could turn on pretend mode, and you could, okay, but I know the globe earthers think it's the real mode. I'm just playing. But you can turn on the equatorial mode, which treats still kind of has the ground as like a grid. It doesn't really involve curvature because they're not like incorporating actual curvature. You've all seen on Stellarium, it just has like a little grass field, but it assumes the ground is part of a huge sphere. And if it's part of a huge sphere Earth with a radius of 4,000 miles, and then it makes the stars a celestial sphere that go all the way around you and around the globe Earth, that's what the equatorial grid does. That's why you can like turn off the grass layer and you can see the stars, quote unquote, underneath your feet. But that's just turning on. I think that's conceptual. Obviously, the globe earthers think that's real. But my whole point is that the stars can be mapped on either one the same. The azimuthal grid is treating it as a planar circle with the stars above. The equatorial grid is treating it as a part of an assumed large sphere with the stars all around you. But either way, the stars are the same. When you flip back between equatorial and azimuthal, the sky remains exactly the same. The only difference is that the equatorial one will, which is the globe one, will assume the stars are under your feet. So if you turn off the ground layer, you can see them down there or whatever. But the actual stars are the same. Therefore, the azimuthal grid, the planar one, is already mapping the stars over a planar Earth.
Yeah, except you have it.
It's already doing it, and it has since the dawn of time.
Except you have it backwards. What Stellarium really
equatorial
does
is the globe one, azimuthal is the planar one.
Oh, except you have it backwards.
But go ahead, I said a lot there. Go ahead.
What it's really doing is using the globe. If you look at the code of Stellarium, it assumes the Earth is a sphere and uses it. And when you go to azimuthal, all it does is cut out half of the stars that you can see. They're still there as far as the program concerns. It just doesn't display it.
Yeah, in your conception, do you think the stars go beneath your feet? That's the difference.
They do. Yeah.
Yeah, that's.
Where do you think they go? Where do you think the sun
wild.
goes when it sets? Do you think of like? You realize that?
Yeah, but dude, that's the contention. We don't really have to go on. It's kind of remedial in terms of the larger discussion. But I mean,
well, I guess what I'm saying.
I'm claiming that they're adding the stars under the feet. You're claiming that they're removing them on the azimuthal one.
That's correct.
But you don't need a globe to begin with. That's the point. All it's doing is mapping the celestial sphere. It's not mapping the ground. Stellarium uses the latitude correlation on the ground of what the stars look like, but it's not saying anything about the shape of the surface.
Yep.
It's not using a globe. It's using the celestial sphere and the graticule and the grid, the coordinate system of the sky, not even of the ground. It just links that to a ground position of the latitude and longitude, but it's really a celestial sphere program. All right, you concede? I don't care if you concede or not. It just is what it is. It's what a planetarium does too. You don't need a globe to make a planetarium either. You don't need to even think of a globe to make a planetarium. You just map the stars above the ground. In a planetarium, none of the stars are below your feet either.
They're programmed though. That's why but you can see you could tell the planetarium to go anywhere in the world and it will do it just like Stellarium. Might if you have a good one. It depends on.
Yeah, because there's a latitude and longitude correlation to right ascension declination on the ground.
Right. Thank you. Which wouldn't work on the flat Earth.
It already does, and it has since the dawn of time.
It wouldn't though.
The azimuthal grid already shows it.
Yeah, why is the azimuthal grid different though? Why do I see different stars on different parts of the world?
Well, another difference with it is that it actually, the azimuthal grid makes like your zenith the top of where above the person, whereas the equatorial uses the Polaris because they're trying to think they're trying to assume that you're on a globe. So like the center of rotation. If you look at the grids on it, if you flip back and forth, you'll see the azimuthal one is making an azimuth around the observer. The equatorial one is making a grid based around the rotation around Polaris, because they're trying to make the idea that you're on a sphere, so the whole rotation is around Polaris. But even on the azimuthal one, you still have the rotation around Polaris. It just adds an azimuthal grid around the observer. You'll see the two grids when you flip back and forth. If I was at home at my computer, I could screen share and show
I've
it.
done
But
that.
yeah. I'm not saying you have to concede the Earth is a stationary plane just because of this, but you would have to admit, if you're being fully kind of intellectually in alignment with this, is that the stars do map over a planar grid, an azimuthal grid. It's like the kinematic equivalence between planar and spherical. Whether you assume they're going under your feet or whether you just leave it as a planar grid, there's an interchangeability. Now, obviously, there will be some difference with curvature, but I'm just saying, like, even if I was a hardcore globe Earth believer right now, I would have to say, yeah, you're right. The stars can be mapped over a planar surface. They have since the dawn of time. Like, I would think you would just have to admit that. You could still say the Earth's a globe. You don't have to concede to the Earth being that. You just have to admit that they map that way, which is what a planetarium is. And they already admit that. The geocentric equivalence. I mean, humanity came out of a planar Earth geocentric thing that already worked. They just added the globe and said, no, here's a different interpretation. All those quotes that Whitsitt has about the equivalences and you can't tell the difference from the ground, all that is relevant with this. And Stellarium shows that. You can't remove it. You can't remove the planar geometry, even in the foundation of Stellarium. All they did was add on to it and say, well, actually, we're on a sphere. We're going to take this different philosophical approach, and therefore we're going to assume the stars are going under our feet and make the celestial sphere expand in that way. They just added that.
Yeah, I don't think that the azimuthal grid you're talking about is a personal dome, like Shane would say.
Well, I mean, dude, you could have an azimuthal grid Stellarium software. You could pull it up on an actual planetarium, which would be a hemispherical dome above a flat floor anywhere on Earth, a planar floor, and a hemispherical planetarium. You can go anywhere on Earth, and you could replicate the exact stars from where that planetarium is. Like if you're in Hawaii, you could set the planetarium for Hawaii where you are, walk outside, look at the stars, walk inside, look at the planetarium, walk outside, look at the stars, you're going to see the same thing. And you could do that with the planar grids all over the world. And all those planar grids all are coplanar. And you can replicate every position of the stars.
They're coplanar, then why can't
around
I
the
see
Earth.
all the? Yeah, but again, I can see different stars if I decide to go look at, I don't know, Sydney, Australia, or something. I'll see a bunch of different stars that I can't see from United States.
Yeah, it's because the celestial sphere is huge. You're not going to see all of it at any one time. But that doesn't refute what I'm saying about the fact that you could make an azimuthal planar grid with a hemisphere of stars and have thousands of planetariums all around the Earth, and they would all match what you actually see in the sky. And all those grids would be coplanar. But obviously the globe would claim that they're not coplanar and that they're actually stuck around the side of a ball. So you'd have to have some other way to prove that it's curving. But the stars themselves already map on all those planar grids.
You know, if you were to do this, you would find that the stars that are overhead in the United States are on the horizon in South America, and the stars that are on the horizon there are over you when you're in Australia, let's say. And you know, it's like almost like you're on a sphere.
Or you're just your
Almost.
perspective,
Not
or
quite.
your perspective changes as you move around.
A very basic question.
Yeah, exactly what QOP said. Your actual position changes due to where you are in that larger grid.
Right.
Because the grid is much larger than you can see.
The actual change, it actually depends on where you are on the globe, correct?
I think it boils down to Ken, a glober in the room, a steel man, a sunset on a flat earth.
Here you said you couldn't.
I don't think they can, honestly.
NASA Shield definitely can't. I got $100 on that.
10.
Who wants it? Who wants it?
On what?
Take your bets.
On what?
On how incompetent you are to Steelman Flat Earth Sunset.
I can't steal.
Is there any
I agree with
that
MC
can do
Toon
it?
here that you
Any
can't
glober that
you
can do
can't
it though?
steel
Like,
man the
think
flat
about
Earth.
it. Can any glober do it? Has any glober actually ever done it?
I can't. No, I cannot steel man the flat Earth. I'm sorry, it is too incomprehensible.
Wait, can a Glover do what?
Steelman
You should
Flat
be
Earth.
able to, bro. At this point, dude, you should be a Steelman expert at this point. You
Can't
should
do it.
know both sides fully. You would think with your passion in this topic.
The amount of time you spent
I can't do it
talking
though.
to
Really,
us, you don't learn anything.
I can't put. I keep on asking you guys for flat Earth
Are you
evidence.
past the age of learning? What's the age of learning
What
that's
is?
capped
I asked
at?
for flat Earth evidence, and you guys never give me any other than it looks flat.
We're not talking. We're talking about sunsets. Pay attention, NASA show.
Battle of the
Sunsets,
beams,
right?
bitch.
Battle of the Beams is
You can't shoot beams
you
in
don't-
straight lines that far.
Battle of the Beams is again, radio is another topic that you guys don't understand.
Well, this is gonna be a joke, but when you say that
Go ahead,
Sorry,
Gio.
this is gonna be a joke, but when you say that, oh, you guys only say it looks flat or whatever, I don't even think anyone's saying that, but this is gonna be a joke. But dude, you should pay $100 for every point that people have beyond it just looks planar, it looks flat or whatever, because you would become very poor very quickly.
I'm asking for the equivalent of the Eratosthenes measurement for the flat Earth, and nobody ever gives me one.
Yeah, the same one,
The Battle of the
Eratosthenes.
Beams. The Battle of
Yeah,
the
do
Beams.
the same one. Just don't have bad assumptions.
The Battle of the Beams
Yeah,
is
the
explained on the
Eratosthenes
globe.
measure
If you
that's a
understand
flat
radio
Earth measurement right there for sure.
and understand how radio transmissions in that frequency work, it would not be. So,
Dude, there's obviously a lot of arguments on all sides. It would be like if someone came to you and said, "Oh, the only thing you say is pictures from space at Ursa Globe." You would know that's not true. So obviously, people say a lot of additional things. So at least you don't have to agree with them, but you should at least agree that there's many, many points, and you should be able to steel man pretty much all of them at this point if you've been listening. Which I'm not trying to attack you, but I wonder if you do kind of not listen as much as just kind of try to tell people they're wrong. I mean, because you should. Why can't you steel man the whole thing? I could steel man the whole thing. I give a 2-hour presentation steel manning the whole thing, if I wanted to. You should be able to too. Both sides, quote unquote sides.
Well, I mean, every flat earther is a little bit different when it comes to their beliefs. So it's hard to steel man a position that changes with individuals.
So we don't have a model.
Yeah, because everyone's unique. Yeah. So what are you actually debating against then? A stationary planar Earth cosmology with different people? All right. Well, then, yeah, you're going to have different
Well,
people.
I guess what I'm saying, it's hard to steel man a position that everybody has.
Yeah, I can steel man it with ease, dog.
Everyone's
Shouldn't be hard.
sunset works the same.
You've been in this community probably much longer than me. You don't do any listening when you're in these conversations?
Oh, I listen a lot. I'm waiting for something that actually has evidence.
So you don't disagree with any flat earther because you can't even clarify what you would be disagreeing with.
Oh, I disagree with the Battle of the Beams is well explained on the globe. The sunsets are explained only on the globe. Celestial navigation
Well,
works
is
only on the
science
globe.
just the pursuit of making explanations?
Yeah, you guys invoke a random evaporation duct in the thermosphere. You say that your ultra high frequency is able to now when it never was before. You required line of sight. Oh, but when it goes too far, it's because we don't need line of sight. And now it's bouncing off of the evaporation duct in the thermosphere.
It wasn't UHF. It was closer to medium frequencies, but that's okay.
Battle of the Beams was ultra high frequency.
I know it was 30 megacycles, which is close to medium frequencies.
How wide was the beam?
No, the whole point of it being the whole point of Battle of the Beams is they were increasing the frequency so it would be like a straight line. It's not panning out like how you think it would with a regular radio wave. This is like a line of sight beam. So no, not medium frequency.
It was 30 megacycles.
What's the width of the beam, NASA?
You mean the interception of the beam?
No,
Can you
what's
steel
the
man? Can
width
you
of
steel
the
man
beam?
Battle of the Beams?
If you're saying that it's all makes sense on the globe, I mean, you must have done some sort of geometric understanding of how that beam is propagating.
Oh, they're going to launch
So
a
I'm just
rocket.
asking you. I mean, how wide is it? How tall is it? I mean, I think I could still man your position better than you can on Battle of the Beams personally right now. All you have to do is just say that it's propagated vertically. It's quite tall, but it's narrow.
That's the antenna.
And you.
That's
No.
From the antenna. That's the way it was collated described. They had two antennas, two beams, and they intersected the beam. Yeah, they're getting ready to launch.
I mean, you're almost there, but okay, cool. You're missing the part where, I mean, like, how do you deal with the height, the different, like, it's going over the curve. You have to perfectly account for all refraction on all days. Like the atmospheric conditions affect the the beam propagation, right?
I got 2 minutes until launch. Let's wait for that. I'll talk to you about that.
You're gonna watch it. What does it do?
Go off. He's gonna wait till people forget that he didn't have an answer.
The
2 minutes to launch.
rocket just starts traveling horizontally, and it'll be like, "See, it's curving."
It goes up vertically, and then they.
Let me know when it goes sideways. Man.
Who do you think would win NASA shill in a steel manning the planar stationary Earth cosmology? Who would do better, you or Matthew Learns? Because I think Matthew Learns would shred. He'd probably shred you out of the water. He would toast you. It sounds like
Anybody
I
would
got
do
money
better
on
than me
Matt.
because I don't. I can't steel man. I agree with MC Toon here. You can't steel man the flat Earth.
Yeah, but steel manning is steel man is giving a good faith best representation of the argument that you possibly can from what the other person is giving you. Even if it doesn't matter if you agree with it or not. You don't have to agree with it at all. Some people confuse that. They conflate it. They think if you're steel manning it, you're asserting it, and they're very, very wrong on that. They'll do that often, and they'll use it to troll a little tactics. Like you'll steel man something, and they'll say, "Oh, so now you're saying that?" You know, it's like, no, I was steel manning. Steel manning it is just a good faith representation of the best aspects of the argument that you can put into words to show that you understand what the person's saying. So if you can't do it, it means you haven't been understanding any of the arguments people have been saying for all these years. It means you don't even know, you haven't even started to even consider them if you can't steel man them. You don't even know what they are yet.
Sunset is like 101, bro. It's like the first.
But he wants
Sunset's
to hear them
101.
every day.
Globe,
He wants to
globe
sit here and
evidence.
listen
Thank
to
you.
the arguments, but not
There's
comprehend
there's no way the sun sets on the flat Earth. None. It's impossible.
I think he's
but that's not what steel man means.
I know what steel man means, but there's no way
You
that
don't even
you're
know
that
the
your
argument.
made up
try to
stuff
steel
can be
man it.
true. I can't. It's too.
It doesn't have to be like a truth.
How can
It
you
just
say
has to
that
be
if
you're
you
steel
can't even
manning the
steel
position.
man the flat Earth position?
It's too silly. What you got?
But what is the silliness?
I don't know. What is it? Perspective and the globe of what is it? What's its new thing? The globe of azimuthal something vision. Geo. Here we go. Liftoff.
This is your steel man?
I can't steel man. I told you I can't
He's trying.
steel man.
Let him go. He's
All right,
squeezing
we'll
it
give you
out.
as much
It's so
time as you
hard.
need. Yeah, dude, any of us in here could give a very solid, like 5-sentence steel man of it. Can you do one?
No.
Well, that shows that I'm not trying to attack you, but you do not know. You don't even know what it is. Then you don't even know what you're
do know
debating
what it
against.
is.
You're just coming in
But I
and just saying it's globe, without even understanding what people are saying. Otherwise, you should be able to steel man it. You don't have to agree with it.
No, I can't steel man it.
All right, can't do it.
I can't steel man it because it's too silly.
Well, then you're disqualified.
Okay.
You know, you can't really debate it then or discuss it or anything because you don't even know it.
Yeah,
DQ'd.
I don't understand why
No,
you're
I
here.
know what it is, and
Like,
I'm waiting for some, something that makes sense. Something that
Says it
scientifically
in his
makes
name.
sense.
He's a
You
NASA
know, we
shill.
should do an experiment. Let's give him the Steel Man, then immediately after see if he can Steel Man.
We could do that. We
Dude.
could all give our steel mans and then see if he could try to put one together after we do them
It's
all.
not a steel man if we give it.
I don't understand. The thing about it is, to steel man something, you need to, you need to understand it, and there's no understanding the flat Earth position on sunsets, for example.
It is like we've all been playing chess for the last 5 years or so, and this guy's just like come in with
Yeah,
no, you're still playing checkers.
No, you've been
You
playing
just think we're
pigeon
playing
chess.
checkers, man.
You've been playing
You just
pigeon
don't. You,
chess.
you just
He's
really don't have
claiming
a
we weren't
clue
even playing the
the-
game with him.
You were playing pigeon
know.
chess, though. That's the thing.
You don't have any clue of the rules of what is it, like the adversarial position. You actually cannot argue against us
There are no
technically
rules,
because you
though.
actually don't even know what we're talking
This guy's
about.
like, I don't remember
So,
playing
But there are
chess
no
with
rules.
you.
You
How
need
did I
you
get
you're
need
not
here?
even playing
evidence.
chess anymore, dude.
Need evidence, and you don't have any.
This is a senile old man who doesn't remember playing chess with us.
How am I supposed to
It's
steel
not
man a
chess.
model? How am I supposed to steel man a model when you don't have a model?
I mean, I think we do sort of have something of a model, so but yeah, you got to argue against others.
NASA Shill, you're one of my favorite Globers because you make such bad arguments.
You can say what you want. I mean, you need evidence for a position, and when you don't have any evidence,
Here, I'm going to Steel Man NASA Show's argument. Eratosthenes, Cavendish, flat Earth is stupid.
Cavendish is not part of this argument.
No, he's steel manning like your position, I think. Like your overall pictures from space.
Yeah, pictures from space are. I mean, you guys just have to say no to that one.
You guys say no to them. You're the ones that say you guys assign colors and it's just data, that you're turning into.
What do you mean
image.
assign
It's not real
colors?
image. It's all black and white, and it's just black and white data or whatever.
Yeah, I guess you can say like
filters.
you could say
Excuse me,
no. Hold on, you could say no to them, or you could say So or no. The thing is, neither of us took those photos and have any way to verify them other than government organizations, if you're talking about those, claim to have taken them. So if you want to try to say someone's saying no, well, you're just saying But no, but I'm not saying either way. I mean, the thing is, but the saying no to them as not being valid when they're not verified. So I'm just saying, you're just saying yes. You're just saying yes and accepting government propaganda from
What
the
do you
other
mean
side.
they're not verified? You can stand outside and see the weather. Satellite took a picture of the weather.
That's not a globe Earth
You
in
understand
space.
that you understand that a lot of these satellites take pictures in frequencies you can't see, right? In infrared.
Isn't
and
the weather
ultraviolet.
not live streamed? Like what is it, that thing that goes around and
So you
takes
want to
the
talk about
video?
satellites, NASA? Why don't you try to respond to the argument I made to you earlier today
Which
about
one?
the camera being within the case for every other satellite except for
Oh
the Parker
God,
Solar Probe?
the camera thing, right? This is similar to the camera on the moon thing, right?
No moon. Not talking about the moon.
I know, but this is a similar thing. You keep on wanting more and more cameras.
I'll just explain it really quick. So the claim is the reason you can't take pictures of the Earth when your satellite is in transit to geostationary orbit to then turn around and start taking pictures of the Earth. The reason you can't do that is because while it's in transit, the environment is so harsh that if the lens was exposed, it would get damaged. So they keep it in a special casing until it reaches that point where it doesn't need to accelerate deeper into space anymore. In the same breath, these guys say that the Parker Solar Probe has been taking pictures while in the coronasphere of the sun. That is a much harsher environment than our atmosphere. So how do you have both?
Because not every camera is a Parker Solar Probe.
So you're saying that satellites can't have cameras on them taking pictures in transit. They just can't afford it, or what?
Well, if you look at the rocket, it's putting all sorts of trash out there. If you have a very
So
expensive
you're making an
camera,
extraordinary claim, right? You're saying you're going from 0 altitude to 15,000 miles, 25,000 miles altitude. And nobody cares to prove that actual traversing through space. It's
But
like
what
you're not taking
you would
pictures
just you would
until
just
you
say
get to your geostationary orbit position.
you would say that those pictures are fake anyway. So
Well, you want your cake and you want to eat it too.
no, you want the cake and not eat it. You want more pictures, and when we give you more pictures, you'll say those pictures are fake.
There is no response to this argument.
Yeah, no, there isn't. It's a silly argument.
No,
I
you
looked
guys
up
think that you
the-
can't take pictures in space, but then you say you can.
You can.
Hey,
Yeah.
Electric. How are you, Electric?
There's a picture coming from Himawari every 10 minutes.
Oh
Electric.
my god. Robert
How are
and
ya?
NASA Show at the same time? This is not a good combo.
My main man Q-Op is here.
Yeah, this guy Robert Silverman, he wasn't able to answer this question either.
Yeah, because
I
it's
look
a
up
silly
in the
question.
sky, Electric, and I see the Starlink
Hey, you guys
satellites.
can't address anything about your model.
Did you
I
watch
You're
the
just
launch?
sitting there, just squawk. You just
No,
squawk.
I see the Starlink satellites in the sky with my naked eyes.
Dude, I don't know if he might be worse than NASA Show. I forget. I just
You
remember.
see
Yeah,
ISS with
he
your
actually
naked eye
might be
too.
dumber than NASA Shell.
Hey, you know what the thing about it is? You can actually, if you look at if you use the ISS and a couple telescopes, you can triangulate it when it say crosses the moon, and figure out its altitude and speed. It's been done.
It's apparent position or
What do you mean
geometric?
apparent? Does it mean where it
Oh my
appears to
God.
be? Yeah, where it appears
It's
to
a
be.
parent holographic reflection.
Yeah, in a parent holographic position against the moon, because everyone knows that the moon, the holographs always have shadows, right?
They can, yeah, dude. I definitely think the moon has a hologram. I think everything in the sky. I mean, light is holographic by nature.
Light is holographic.
Consciousness
Wait a
is
minute.
holographic.
Consciousness is holographic.
Hold on a second. You don't
Absolutely.
really believe that, do you?
Consciousness and light are holographic. Absolutely. The principles of holography,
No,
which
no,
is
that's
also
not what
what interferometry is, essentially splitting a light beam. That's what all of consciousness is. Everything is essentially split light into frequency and vibration, which creates all of reality.
No, I was talking about the moon. Do you think the moon is a hologram?
I think all the lights in the sky, the celestial bodies, have holographic qualities to their light emissions. Yes, I'm not saying it is a hologram in the way of like the way that we create them on Earth per se, but yes, it does seem to be that the light has the holographic qualities to it.
And
No,
here
the
we
moon.
go.
The moon. The moon. Not. I'm not talking about the lights. The moon.
Yeah, the sun, the moon, the stars.
And
No, the
boom,
moon.
stuck the landing. Good
The
job.
moon doesn't have light. It's just there's no light from the moon. It's just.
Yes, it's a fluorescent silver light. It emits light. Yes, it's a fluorescent
So it
emitting
has
object.
Wait, so it has its
Oh
own
my
light?
god. Oh my god. Did you just say the moon doesn't have the moon was so bright
It doesn't
last
have
night,
its
dude.
own
It's
light.
crazy.
It doesn't have its own light.
It's reflected.
Doesn't
It's reflected from the sun.
Exactly. It doesn't have its own light.
It is its own unique silver luminescent object. Absolutely.
Okay, that's my question.
Anyone-
So, hold on, Q-Op. Can I please ask you a question? I'm sorry.
Like a fluorescent light bulb in the sky. Dude, you ever been out on a full moon? That's not reflected. That's not a reflected rock.
No,
It's
no,
not a
Gio, hold
reflected
on.
light off a rock.
So your
Reflected
belief,
light off rock,
and
yes.
your belief, Gio, is that the moon has its own light source.
It's not a
Lights are-
belief.
This
Is
guy
moonlight
thinks
cold?
NASA can't afford cameras.
It's a
Like, you're
direct
saying.
Moonlight,
empirical
is moonlight
observation.
cold? Is moonlight cold?
No, hold
Oh,
on, NASA.
don't spoil it. I was about to ask Robert about that. Don't spoil it, NASA Show.
I want to
moonlight
know
cold?
what I'm asking Gio an honest question. If he believes that the moon has its own built-in light source.
Yes. That's what we believe. Robert.
Yeah, but I wouldn't use the word belief because it's a direct empirical observation. There's no need to have any belief or theories on it. It is empirically
Gio.
observed as an object that emits its own light. Yes.
Okay, hold on.
Yeah,
Gio,
this guy walks around with his
NASA-
eyes closed. He doesn't.
Wait,
pay
Electric,
attention to
please. I'm
reality.
asking you. Why can't I just ask you a question? Why does everyone have to do that? I'm asking you for your belief as a grown man. You believe that the Earth the moon has its own light source built in.
You asked that already.
I just want to clarify because he keeps saying I don't have to believe it.
Yeah, because I just said, I'm saying you're asking me. It's kind of it's a little bit of a loaded question because you're saying
No,
you
it's not.
believe, and I never claimed anything about the word belief. We'd have to define what you mean by that. I'm just saying that there's no need to theorize on it. It's a directly observable empirical fact that the sun or the moon is an object that emits its own light that you can observe, and it lights up the entire world around you.
I apologize. Let me rephrase. You think that the moon has its own light source built in.
Yeah, I mean, I haven't been to the sky, and none of us have to like get a sample or look, touch it or see what it's made of or anything. So all humans, I think, since the dawn of time, we're left to, in a sense, speculate about what the sky is. We can wonder, we can dream, we can check
No,
it
not the
out,
sky.
and take a look at it. However, empirically, yes, the moon appears to emit its own light from Earth.
Okay, but that's what you wholeheartedly think is that that's what it happens.
Absolutely, that is how creation
That's
has
all I
occurred.
want. Okay, that's all I want to know. Thank you.
The stars emit their own light. This moon emits its own light.
No,
The sun emits its own light.
Of course.
And
Well, the stars.
in essentially in all of the ancient scriptures, going back not only biblical but other like Vedics as well, the Vedic scriptures, they all refer to the moon in terms of creation as being its own light. It is only this current heliocentric theory that has been pushed that claims that it's reflected light from the sun, that it's a rock. That is the only one in the kind of current government propagandized cosmology that claims that. All of the ancients, and also you can empirically observe the moon emits its own light, and you can measure its qualities as well.
Well, the moon is not government propaganda. It's in the sky.
No, but the part where they claim that it's reflected sunlight, that it's a rock and it's reflected sunlight, that I'm saying is the current government propagandized, because it's only current. We don't have to bring in the government. It's fine. I mean, I do think they use it as their thing. I mean, there's claims that there's earlier history before the current governments, but I'm just saying the current heliocentric model, as it were, of the Earth as a sphere and all that, that's the only one that claims that it's reflected. All the ancient spiritual wisdom traditions going back since the dawn of time, and what's empirically observed is that the moon emits its own unique silvery, fluorescent, luminescent light that it as an object.
Interesting.
All right, now Rob Silverman, can you steel man Geo's claim?
I have no desire to speak to Electric. You're not a nice
I don't
person.
think you can steel man it, even though he just told
You're
us
not a
you.
nice person. You insult people and call them names.
This is getting good.
You won't do that here, right, Electric? You won't call me the names
You
called me.
can't steel man Geo's claim. He literally just told
No,
us.
Electric. Will you call me the names you called me in the other server on here? I doubt you think you will.
We might allow it. Oh, we need. What are they?
I won't
love
allow it.
people
Okay, Robert. I'll mod. I'll stay out of the conversation.
We might allow that. A couple, at least one or two.
We'll turn off all moderation for
Electric.
5 minutes.
Electric, go for it. Tell them what you said.
The rule.
Tell them what you said.
The rule
Electric.
is the rule. What was the rule? The rule is that what is it? If you can't be polite, you've got to at least be funny, implying that you're allowed to insult people, but it's only if people get giggles out of it. Okay.
Exactly.
I wasn't.
So,
insulting.
I mean, Robert, if you want to go back to your safe space, feel free.
I wasn't insulting. I was just asking Gio an honest question. I didn't insult him.
Let's clear the room for Bobby and Electric. Let's clear it. Let's see what they got. Let's see the little chemistry that they have here.
No, this is gonna get filthy. Let's go.
You don't want
it. You can measure. We did a live stream on here actually, where like 5 different people were live streaming their through their phones, and taking measurements of the moon temperature. So that's a whole topic in and of itself, that you can validate that the moonlight is indeed different than the sunlight. And there's no way to have reflected light actually cool, makes things colder. So there is that component. Also, just empirically, observationally, the moon is a very light, luminescent. It just doesn't have the specular highlights, which it would if it was a rock reflecting sunlight. It would not. And when you look into the inverse square law of how bright the moon is, the astronauts would be blinded by the light. They're up there. It's a dingy, dark surface. That is not what we see on Earth. And you could look at the inverse square law of light to show that it does not correlate, that the brightness would have literally been blinding them when you do the actual inverse square law. So there's a bunch of ways to validate that the moon is not a reflected rock, sunlight.
So
and that it is its own light.
Did you say the moonlight is cold?
It seems to have a cooling effect, yeah. Whether it's actually cold, like emitting cold, or whether it's absorbing infrared heat. It's either absorbing infrared heat or emitting coldness. I don't know that I've isolated which one of those, but it definitely makes things colder. That's why, like, if it's like a full moon, it's been a hot day. When that full moon comes around, it stirs up the air, makes it a lot colder. You feel the cold.
So you understand that that's a second law of thermodynamics violation, a real one, not a fake one that you guys always make up.
You can have supercooling lasers.
So do you think that the heat
you think
is
that
like
the
just
sun-
what
the moon
radiated
is-
off the Earth? Like once it's into our environment, I don't understand like how space conducts it or radiates the heat. That doesn't make sense to me.
Let's get back to Bobby and Electric.
Oh God, you don't want it.
He doesn't want to do it, dude. He knows he's going to get destroyed.
I don't want to do it.
I
because-
All I
want
got to
it.
do is ask him for globe evidence, and he's already done.
No, that's not true. I don't want to have you insulting me like you always do. I don't think it's correct. It's not nice. It's not nice to talk about my children or my wife or my family. It's just not acceptable. I don't want to have.
Why
to
were
deal
you
with it.
doing it to me then?
I didn't. I did not.
Stop bringing drums from other places into here. We could have a debate about your model.
But
Let's
you
do
know
that.
what you did. You know what you did, Electric.
I'll
I'm not
probably do
gonna
it
repeat.
again too if you keep doing what you do. So.
You might
Go
have to
ahead.
reset it. Eh?
I'd
But
love
yeah,
for
if
you.
you want to be a drama queen or you want to defend your globe, what do you want to do?
You want to know what? You want to know what I told him, Levelist? He said he had a roommate. He told me he had a roommate, and he said because rent is expensive, so I told him to get a job. Is that insulting his family? No.
Well, there's just no need to go personal. You don't know whether he has a job or not. Dude, people have jobs that have roommates.
And then
I mean,
you know what he said, Gio? And you know
why
what
does
he
This
that
dude
said?
lives in a bubble. He doesn't know what it's like to like have a job.
And then you know what he said, Gio? He said that
I have
my.
a lot of
and then
people.
he said. Then he
You
said
know, I
that
have
my.
roommates because I like being. I don't like being alone in a house, dude, and I don't have to pay as much for rent. And it's convenient to know that somebody's home. That's always nice for me. I like
Then-
having roommates. I like
then he
people.
went on
I don't
to
know. You want to
say-
be alone? Where's your family?
Then he went on to call my children mentally retarded, which I took offense to, which was not nice.
Yeah, it could get worse than that, dude.
So that's why I don't want to get into a discussion. That's all.
All right, well, let's not go after anyone's children. I don't know what conversation you guys had elsewhere, but
Yeah, I don't know
well,
why he's bringing it up. We should be
Well,
talking
that's what he
about
did.
globe
That's what he
evidence.
did.
Rob, present globe evidence.
I do all the time, and you guys just don't want to listen to me. So I don't want. I'm just listening.
We're
in here.
listening. You have the floor.
I'm listening to you guys. That's all. I'm just listening in.
So you don't want to defend the globe.
I asked Gio for as honest.
So just say that you don't know how to defend the globe.
No, I do, but I asked Gio what he honestly thought the moon had its own light. I just wanted to hear him say it. That's all. Nothing wrong with me
Yes.
asking a question.
I mean, I have not been to the moon, and so I can't come with any like direct. Like if it is even a place you could go to, if you could go there and actually see what it is, then somebody could have more of like a full truth claim, to that extent. But obviously, none of us have been able to tangibly touch that object, if it even is a tangible object. There's claims that these government guys did it, but it's a whole nother deal.
But you could
Hey,
see it with
Gio,
a telescope, though, right?
Gio, I wasn't here the night that everybody popped on their camera for the moon temp. What were the outcomes? I mean, I've done it myself, but I only got like 1 or 2 degree Fahrenheit difference.
Yeah, dude, it's in the pinned messages. Let me see. Oh yeah, it's in the pinned messages here. I made it into its own actual stream. So it was Cyrus was testing it. Silly questions. Travis was testing it. Redford Bear. Here, it's right here. I'll post the link. This is basically just like the cut from the live stream when it happened. I don't think it shows thumbnail, but
they get something similar, like 2 or 3 degrees Fahrenheit.
Yeah, they were all doing it live, measuring the moonlight, and they got. What was interesting is that, like, I think Cyrus, he did it on a bunch of locations, and he got like 2 to 3 degrees. Some of his were even 4. I think one of them was as much as 5. You can watch the video here. I'll post it in the chat. It's that one, the Rumble. It's just like a cut from the live stream. And then what was interesting is that Travis, who is and they were all doing it at the same time, like simultaneously. And silly questions, Travis, he was in Colorado, and he was getting like, I believe, like 7 or 8 degrees. So it was interesting that the higher altitude, rendered him colder than the guys that were closer to, like Cyrus is in Arizona, for example.
Higher and thinner atmosphere, yeah.
Yeah.
That makes sense.
And then Redford Bear was in Canada, and I don't know if I remember offhand. I know she was maybe getting like maybe 2 to 3, but I'd have to go because it's been a while since I've seen that.
So that's our
Anywhere,
evidence,
between
Bobby.
like 3 to 7 degrees colder in the moonlight than in the moon shade. Yeah, that was the overall from a bunch of people all doing it simultaneously, which is what others get too. Roughly that 3 to 7 degree range.
So from the newest member of the top 5 Globe Earth debaters, Bobby, can we get your thoughts and feelings on our findings on moonlight temperature differentials?
First of all, nobody calls me Bobby.
I just did, so.
Yeah, but I don't respond to that, so.
Okay, well then just go back on mute then.
Yeah, Rob, you got to figure out why you're here, dude.
You could address me by Robert, and I'll respond, but nobody calls me Bobby.
Okay, Bobby. At least I would know how to shut you up now,
so like, are you doing the NASA?
I mean, Levelist does call Jeremy Jerome, so
everybody gets a nickname, Bobby.
So I'm just wondering, Rob Silverman, are you ever going to be able to steel man this position? Like when you spend time in here, are you going to be like a NASA shill and not ever actually absorb information?
It's funny. I see what you did there with the NASA show because that's actually someone's name.
Yeah, I want to know what these guys think they're doing when they spend time in here.
Well, Robert, do you agree that if the moonlight is measurably colder and if you were able to do this yourself in whatever conditions you wanted to, would that validate for you that it's not reflected sunlight? Because reflected hot sunlight is not going to make something colder. And if you can measure the coldness yourself, would that validate that would lean towards or indicate that the moon is the own light?
You're roboting. I couldn't hear you. There's a little roboting going on there.
What I was saying is that if you were able to measure the moonlight yourself to be colder, would that help you differentiate that the moon is not a reflected light off a hot sun, but in fact is its own emitting its own light? If it can make things colder, that was the question.
Well, first of all, thank you for calling me by my name. I appreciate that. Number two, I disagree with your guys' belief that the moon has its own light. I completely and wholeheartedly disagree with that. I don't want to get into a whole debate about it because it's just going to lead nowhere. So I just was asking a question. That's all. I just like to listen to see what you guys have to say and just listen in. That's all. That's all I'm here to do. I'm not here to insult people or anything like that. I just wanted to listen in and see what you guys were talking about. I was listening.
Are you going to wait till you go to Omnivores to do that?
I was listening in when you guys were talking about the celestial theodolites and all that stuff, and I just want to hear what you guys have to say. That's all.
So you don't want to answer Gio's question?
Yeah, just keep throwing him jabs. Just keep throwing him negative jabs. Keep throwing toxic into the well, and then when he gives you some toxic back, why are you acting like that, Glober?
Yeah.
Well, hold on. I did ask an actual. It's fine if you don't. I hear you. Your response that I hear you, but do you have any response to what I said? Because you were asking me why I think the moonlight is colder. I'm giving you, or why it's its own light. I'm giving you a test you can do, and actually a video of a bunch of other people doing it too. So you don't have to answer it if you don't want. But the question is, if you measured it colder yourself with your own equipment in your own way, would that help you differentiate between the moon being its own light or being reflected sunlight?
Not at all. Not at all, because there's no way that the moon has its own light, and we've been to the moon, so it's not like anyone's never been there before. We have been to the moon.
That's a great answer,
You've
bro.
been to a light?
We've been to the moon.
That was like probably
You're
one
into
of the
a lot.
best answers I've ever heard in here.
It was perfect.
Just because you don't believe we've been to the moon doesn't mean we haven't been there.
You've been there personally.
Just because
No,
you
not
believe
we,
you've been to the
not
moon doesn't mean you've been
people,
there.
the human being. A human
Yeah,
being.
exactly.
A human being.
Yeah, but that's starting to defer to other people that we can't validate and so on. But my question, okay, then how could if you measured it colder, how could that be the theory that it is a rock that's reflecting sunlight from the sun? How could that theory be true if the moonlight is colder?
But it doesn't measure colder. That's what you just say it does.
Well, it's not.
I said. My question was, if you tested it yourself, you're right. I am saying it because many people have tested it, and there's a ton of information and data and evidence of that. But I know that you haven't. But my question was, if you measured it yourself with all of your own equipment, that was my question, not depending on anyone else.
Yeah, like you did it.
I would never, ever, ever, ever think that the moon emits its own light.
I would never, ever, ever think it's 240,000 miles away.
It is.
Mm-hmm. Yeah.
It is too. We know that to be a fact. It's that far away.
How do you know
It's
that?
like we went to the moon, right?
Of course come on. I don't want to get into this argument. Seriously, you guys are trying to get a rise out of me. It's
No,
okay.
I'm just using your own logic. Like I'm just walking it down the.
I
down the
understand a
line.
lot of people think it's a big conspiracy that we never went to the moon. There's a lot of people that think that. That's fine. That's your belief. You're entitled to your belief. I respect your belief, but it doesn't mean it's true.
Right, I
It's not a
respect your
belief, bro.
belief
The belief
that,
is that
that
we
the
did,
moon is
bro.
240,000 miles away. I respect that belief.
That's empirically true. We don't have to
Yeah, the
debate.
person that was supposed to have gone to the moon, he literally said, "We never went."
That's come on level. I
He
mean,
said it 3
like,
times that they didn't go.
Yeah, 3 times
Yeah.
actually.
Sure. Okay.
And I can show you
Well,
all
I mean,
the astronauts
Robert, just to give you an
that,
example,
died
though.
in the 80s. I can show them to you right now.
Have we been?
If you guys want to go, well, hold on. I might be.
Hold on, Gio. Wait a second. Have we? Are we orbiting the Earth right now on the ISS?
We.
Who's we? No.
Human
America.
beings. Human
America.
beings. Not America, because there's different countries up there, but human beings in the ISS orbiting the Earth right now.
Yeah, the bear and the eagle are up there. Yeah, because the USA and Russia can only agree on one thing.
I mean, I can show
War.
you the ISS
We
underwater
have
in
different
Texas.
sides of the ISS, and they get into altercation.
Does that count? Like if I show it to you underwater in Texas and Houston? Is that what you mean?
Oh! You mean like you're saying there's a replica, so everything is fake? Is that what you're saying?
Well, there's definitely something above us. It's just not what you think it is. It's a U-2 remodified bomber that goes very, very high in the atmosphere.
Bro, every time
But-
Robert
but it
comes in
looks
here,
like
he
the
leads us
ISS.
through these fucking
Does look like the
series of
ISS.
really simple questions for conspiracy theorists, and then we fall for it and just
But it looks like
It's
answer questions
2016
random
all
the
over
whole
again,
time.
Quap. Bobby just learned about flat Earth like 2 weeks ago. Like
You know,
it's
I
2016
take-
all over again, dude.
Why doesn't he just
Levelist-
listen instead?
Levelist.
We could have
Levelist,
deeper conversations. You could learn more if you just listen instead of ask like really basic questions, bro.
I asked an honest question to Gio, and he gave me an honest answer. At least the guy's
It's a lot of-
respectful.
It's a lot of basic questions.
At least he's respectful. He gave an honest answer.
I don't need to respect you.
Except for
I respect
Levelist.
your beliefs, Robert. I respect them.
Well, I
don't.
appreciate that. Thank you, Wolfie.
I disrespect you.
The Levelist wants to insult me by calling me Bobby, and that's not nice.
That is your name.
No, it's not my name. My name is Robert. And I'm the only one on here
That's my name for you. So how can it not be your
I'm
name?
the only one on here with their real name posted.
You can't be in the club if you haven't got a nickname.
That's my
Robert.
real name.
Exactly, dude.
You can look me
Can't
up
be in
and
the
track
club
me
otherwise.
down. You can find me where I'm easy. I'm easy to find. Google
It's
me.
a term of endearment, Bobby. Just take it. It's with
Nobody
love
calls
that I say it.
Nobody calls me Bobby.
There's at least one person that does.
He calls me Bobby.
Nobody calls
Calm
me Bobby.
down, Francis. Nobody calls me Francis.
Nobody calls me Bobby.
Nobody makes me bleed my own blood.
Anyways,
Well, dude, there's a lot of directions of conversation. I got to go on mute for a minute. There's a lot of directions it could go from here because you brought up like moon landing and then ISSs and stuff. I guess just to loop back to it, the thing is, I will tell you this: the Globe Earth guys will claim that the moonlight doesn't make things colder because if it did, they would have to admit that the theory that the moon is reflected sunlight is false. So that's why I asked you if you did it yourself, and I'm telling you that it does matter to all these other Globe guys because if that's why they claim it just doesn't happen, even though it's been shown to happen. You can do it, you can measure it yourself, but they'll just claim that it doesn't because if it did, it would make them. It would basically be a huge problem for the heliocentric theory that it's reflected sunlight, and it would indicate that it is its own light in order to have an actual cooling effect in a unique way that a reflected rock, from sunlight wouldn't be able to do. So I'm just saying it is important to them to the point to where they have to just claim it doesn't happen. But like you can test it yourself.
yeah, I mean, Dave Weiss goes around saying the moonlight's cold. I mean, that's the kind of people that say it.
Doesn't matter about saying it. He just said you could test it, bro. Did you hear that part?
It's not been tested. That's what you say. It hasn't been tested.
Hasn't been tested?
Yeah, show me a real thing with.
We all have laser thermometers because it's so
No, it
easy to
doesn't-
do and show you
No,
guys.
that's not how you can test it.
Oh, that's not how
So
you do
tell
it.
us how to do it, Bobby. How do we do it?
That's like
Or
who's
ask me
that
what I
guy-
think it is. Either one.
Who was that guy who pointed a laser thermometer at the sun? Who was that guy?
Oh my
CC?
god. Oh my god.
What was his name? CC? What was that guy who did? Some guy pointed a laser thermometer at the sun to show that the sun is
I
only.
hate you so much, dude.
No, but
Robert,
somebody
I
did
would
that.
probably focus on talking to people that are here and then making claims about claims that are
No,
made
but
here,
somebody
right?
did it. I saw a video of it. Somebody posted.
Was that someone here? Was that someone on this Discord server, or is that
But I haven't-
some
who-
random person?
That one time he saw it though, Gally.
Ask me what I think
No,
the
but
moon
who-
is, Robert.
Who? Who am I talking to?
Wolfie. Yeah.
Oh, okay. Well, what do you think the moon is, Wolfie?
I think it's a cathode, and it's basically like a plasma in a different medium because, well, for a lot of reasons, but I think the sun is an interactive object with it, and it has like an electro relationship, like a cathode and anode. And I think that just like the scientists before NASA went to the moon said that it's like a plasma, and then they said that the Americans will never go there. A lot of really brilliant guys, Russian guys, and then they got canceled type deal. I think it's basically what they're saying, which is like a plasma.
That was an Aussie dude.
Are you saying that honestly, or are you saying that just to troll?
Why would I troll you?
I don't know.
I'll get the video for you right now.
It sounds.
I think
It
you want to
sounds.
see this
So,
one.
it sounds so far fetched. I have to. I have to really.
No,
say that
because
this
you
is-
just believe everything you're given by
Yeah.
the government.
Now give him a Quap, don't
Well,
trigger
I mean,
him.
I
Okay,
don't-
get the video.
Yeah, you don't need to say
Someone
that,
get the.
Yeah,
This
somebody
is
get the
interesting.
video. That's a
No,
good
'cause
start,
you
right?
can
There's a
look
lot
at
of
the moon-
reasons why I said that, though, not just like
You
one
can-
reason.
You can look at the moon with the telescope. I mean, it's like it's not like it's not there. It's there in the sky.
Oh god. Oh god. Why do we talk to him,
I never said it wasn't there. I mean, I know it's there.
bro? Are you okay, dude?
Q-Op,
Are you vaccinated,
Q-Op,
dude?
you're
Did you
supposed
hear
to
what
be
you
in a-
just said? No one
Q-Op, you're
said the
supposed to-
moon isn't there, dude. Are you crazy?
Q-Op, you're supposed to be in a rave, dude. Come on, go back to the rave.
Q-Op can't dance.
Is that an insult?
He was
I
at
can't
he
dance.
was at a rave. He was
I can't
broadcasting
dance?
it live. He was
Literally like the
broadcasting
rave
it
king.
live like a week ago in here. He was at
All right,
a
I
rave.
shared
Like
the video with you where the scientist from Russia claims that the moon is made out of plasma before they ever claimed to land on the moon.
Q-Op was at a rave like a week ago, and he was broadcasting live streaming.
Robert,
Yeah,
have
as
you
far as I
ever
know,
looked
there
at
was a-
something someone's posted in chat for you to look at?
I'm going to look at it in a minute, but I just wanted to bring up something because Q-Op said when Austin Whitsitt was in here recently, Q-Op said that Austin Whitsitt wasn't in Antarctica, but he was.
Or you just spiral from different topics that you can't like address
No, because
anything of, and you
no,
just
because
go to a
Q-Op-
different one.
Not a
I just
single
want-
thing.
I just want Q-Op's explanation for that. I just want to know.
Dude, I'm tired, bro, and you just like stay on one topic for like you got like
Alright, sorry.
ADHD or something.
Well, how do you like? Okay, I mean, not a bad question, right? But how do you like know that the moon? Like, how do you know for sure that the moon is 240,000 miles away?
How do we know for sure?
Yeah, like
How do you know for sure?
measured it.
Not we. How do you know for sure?
It's been measured. We know.
No, that's not what I said.
I don't have to measure it to know.
Oh, okay, all right.
It's been measured. The scientific community, it's been measured.
I mean, the same scientific community that gave us 21 billion inoculations in the last 4 years. Is that what you're
Actually,
talking about?
anyone could measure it. It doesn't. You could do it on your own.
Thank you for shopping.
Yeah, that's why I was asking about you. You know what I mean? Not necessarily.
I don't. It's like
Yo, your
I've
your
never
mic's
been-
on, brother.
I've never been to Australia. It doesn't mean Australia doesn't exist.
Strong
You don't
man.
have to- you
Well,
don't
I
have
mean,
to
that's
go-
a little different, I'd say, but
No, it's the same type of argument, man.
yeah,
I'm
but that's
here,
like
Robert,
that's
don't
like
worry.
6,000 miles away from me, as opposed to 240,000. You know what I mean? And like, there's also not really a lot of evidence.
Have we been to
I got
Mars?
into an argument. I got into an
Have
argument
we
yesterday.
been to Mars, dude? He's asking flat earthers if we've been to Mars, dude. This guy's a joke.
Oh, Robert, the answer is you don't know. You just believe what men said to you.
What?
So-
I don't know what.
Masonic
I don't know
men.
What
you
don't I know?
don't know that we've been to the moon. You don't know that's 238,000 miles away.
Yeah, yes,
You just
we do
believe
know.
what men told you. You don't
No, it's
know.
not
You
true.
believe
I don't
that.
just- Excuse
You
me,
don't know, we
Galatrax.
haven't been to the moon.
Excuse me,
They could have
Galatrax.
gone,
I don't.
but it could be something else.
You don't
Galatrax.
believe what men told
don't
you,
know that.
Robert?
Galatrax, can I answer your question, please?
You don't believe what men told you?
I don't just believe anything. Okay,
I didn't say just. Didn't say
Yes, you
just.
literally do. You
No,
believe that they
no, I
fucking.
don't.
You believe that little red dot in the sky that they travel to it, and it's a desert place,
Stop
and they
asking
drive
you
a remote control
questions and
car,
let you
control
answer,
it
and then
live
talk
Why
from
don't you let me answer?
from the United States.
I don't know why I can't even answer your question. You asked me a question. You don't let me answer you.
Well, could I ask it? Because you answered it
Go ahead.
incorrectly. You answered a different question.
Yeah,
So my question is, do you just believe? I'm sorry. Do you believe that it's 238,000 miles away because men told you? Is that why you believe it?
I believe that it's the distance that it is away because brilliant people have calculated the distance to the moon from the Earth, and actually anybody that could do it. It doesn't need to be a brilliant person.
Are there any corporations that are corrupt that you believe in?
What kind of corporations?
Anything, any big group of men.
His answer was yes, by the way.
What do
He
you mean, like
believes it
wait,
because men told him. He just
no,
added
no.
all that
Are you?
extra stuff.
Q-Up asked me
Is
another
pharma
question.
trustworthy? Big tobacco.
He
Bob,
doesn't
let him
trust
go. Let
pharma.
him
He
go
didn't
one
get the
question at a
COVID
time. Bob.
vaccine.
You can go next.
I don't know why you can't let me answer the question. Are you mean like an Nvidia or an Apple isn't trustworthy? What kind of company?
Anything that you. Is there anyone that you don't?
BlackRock?
Any
How
corporation you
about
don't trust?
BlackRock?
Agency.
Okay.
Dude, but his
corporation.
answer is not that. It's not really that. I mean, that's understandable that what he said. Like, that is kind of the mainstream perspective, is that they trust that some experts basically did it and measured it, you know? But it's
No,
one of
but
those things like, dude, I trust some things. When I take my car to the mechanic, I trust them and, you know, they do a good job and all that. So it's just, you're just trusting these guys. And the thing is, a lot of us have looked into it and found out like what's actually behind their claims. And it's not the same as taking your car to a mechanic, like with cosmology. That's the thing.
no,
It's not the same. It's like a different category. So trusting them, I think, is problematic when you really look into it. Whereas trusting your mechanic might not necessarily be a problem.
well, the difference is that if you know how to calculate it, I'm not that smart with that type of stuff, but you could actually do the math yourself and calculate the distance to the moon.
Yeah, but math isn't science.
Measure it first, man.
So it's not like you have
Well, that's
to
the thing.
trust.
So we can get into that. See, that's the thing. We can get into where the assumptions are. Because that's why a lot of, dude, if it could be verified, we wouldn't be here at the end of the day. And when you look into how they calculated it, it's a calculation based on a ratio. That's the problem. And it utilizes foundational assumptions.
The thing is that it has been verified, but you guys don't believe the verification.
No, it's been there's assumptions. There's assumptions behind the claim of the verification. That's the problem. What they use is it uses foundational assumption in the actual calculation. It's based on a ratio, not on an actual physical measurement of distance.
Well, I disagree, but that's okay.
It's a calculated ratio.
But I want to ask. I want to answer Q-Op's question about these corporations. Yeah, big pharma. They're scumbags. Tobacco scumbags. Yeah, I agree with that. Yeah.
Okay, so a big group of men can
Nothing
be
to do with
corrupt,
the moon.
and they can be. So people in pharma, like there's people in pharma that don't think they're doing bad things, right? So they're
Nothing to
just
do with the moon,
sheep.
though.
What?
There's nothing to do with the moon, though.
Okay, I'm just trying to get you there, like logically. Like the big pharma is made of lots of people that aren't all evil, right? It's just the people at the top. So there could be a government agency where not everyone's evil. Scientists think they're doing science, and they're just people at the top that are controlling what they do and how they think of everything. And then they tell it to you, and you think, oh, these scientists, they're very smart, so I trust them. But you're basically trusting pharmacists. It's like the same thing.
Did you know NASA has a massive and brilliant budget for Hollywood and film?
Like I said, I don't know what that has to do with the moon, but
well, I mean, maybe we'll get you there.
You can't
connect that. The first director of NASA was a Hollywood mogul, so.
Yeah, Stanley Kubrick.
Listen, listen. You guys, I get it. You guys like to think outside the box.
Stanley Kubrick was admittedly there's a video of him literally he helped with the moon landing footage, so that's not even a conspiracy.
I get it. I understand your point about everything.
You like
you guys
to think critically.
You want to think just because somebody says something, it's not. You want to really think about it and try and think about it and say this. I can't just trust things blindly. That's basically what you're saying.
Is that a bad thing, Bobby? Bobby, is that a bad thing?
Believe anybody just
no. That's kind of what I'm saying.
I would respond to levels
very vague.
saying Bobby, and that's not nice.
Then don't respond to me then.
I've asked you nicely to please stop calling me Bobby, and you don't.
I'm not going to do it. So either respond or not.
I'm asking you nicely. Please stop doing
Bobby,
it.
I think it's funny.
Let's go, Bobby. Let's go, Bobby.
Let's go. Oh, don't mute Bobby. Oh, he left. Oh, he
How
definitely.
does that work, though? By the way,
You
how
just
can
scared him.
you say it's Robert, but it's Bobby? It's like saying Big, but it's
That's
Hey guys, Bobby
the,
doesn't like it
the
when you call him Bobby. Okay, so let's not
the
call him Bobby.
nickname. The nickname for Robert is Bobby. That's what everybody calls Robert.
It would be
Yeah, okay,
ridiculous
Breaker. It
if you
actually
said
hurts me to
Robert.
do. It actually hurts me to do that, but you should have heard what he was saying.
let's use our names that we can best
Like
respond to.
I like talking to the most whatever Glovers, and they camp and they just slander everyone. They'll just pick some random person and then just dig into them for like
Well, let them
sometimes
get
way too
into it.
long.
Man, I
We
was gonna
can
start
skip.
talking about
We
Project
can skip
Paperclip,
them.
bro. How all the fucking 25 scientists all studied brain function and psychology and the anatomy of the brain, and they weren't rocket scientists. I was about to go in.
That guy's really
Yeah, I was
listening
actually
to this.
looking up how much money they actually spend for cinematography and their film production. And right here it says $3.2 billion.
Oh, it's
Didn't
massive.
NASA doesn't
Yeah.
NASA admittedly like hire like a I forget what they said, like a augmented reality company or something like that?
Well, if you name a movie, right, that has to do with space, I'll tell you if they were involved in it with their budget. The answer is all of them, basically.
Damn. Hey guys, can I tell you
Like
something?
Independence Day. I love that movie. Great fucking movie, dude. Independence Day. Oh my god, that's a great movie. They were involved in that
I
one.
made an amazing observation today, guys. Can I tell you about it?
I hope you do.
If you allow me, if you indulge me. My name is Var, by the way. I'm from Finland.
Can we call you Bobby?
Sure, man. Call me whatever you want.
Okay, thanks, Bobby. Go ahead.
Welcome along, Bar.
So, quick question to everybody. You think the sun is an actual sun or is it a parent?
It's a ball of nuclear fusion in a vacuum of space
Good question.
in its geometric position.
I'm gonna
It's
lean
the
towards
globe spins
apparent.
backwards.
I'm going to ask
my
my
answer.
question again. Do you think the sun is actual, as in physical, or do you think it's apparent?
Apparent for me.
Yeah,
Anybody else?
I'm not sure it is.
I think
Maybe it
I
has
think
a
it's a
body.
parent too, like it's our daddy. It's our parent.
I think the source could be somewhere else, if that helps. The source of the
Yes.
energy.
I made an amazing
I think Yahweh.
observation. Guys, I know how to prove that the sun is apparent. First of all, take an object in your environment, wherever you are in your room. Make something that's quite far away that you have to, look at it. Then what you do is you close one of your eyes, look at it, the object, and you close the other eye and you keep looking at it. You can see that it's there, it doesn't really change position. If you do the same thing with the sun, if you can get used to the amount of light, if you just stare at the sun, it's not going to hurt you, it's not going to make your vision worse, it's just light, and your eyes get used to a certain amount of light once you can just, stare at it. So the sun is bright, but if you keep staring at it in the sky, you can get used to the light and you can see the just the circle of light, the sun. But if you close one of your eyes and then close the other one and look at the sun, it actually changes position in the sky.
Dude, that could happen with anything if you block one eye and then block the other eye.
Wait, but he
Oh,
just
I'm
said
telling
it
you,
didn't
man, 'cause
happen with
it's
his other thing. I mean, I want to try that.
no. Listen.
You said
You
it
do
didn't
that.
happen with the first thing, right?
Yeah.
Yeah, that's what I thought you said. I'm gonna try it right now. I'll be right back.
There you go. I mean, you
Well,
can argue that
if you block one eye
it's
and
so
look
far
at something,
away. I mean, you can argue that if you do the same thing with an object in your room or in closer vicinity, that doesn't happen like that. It has to be far away. You can try that with the moon. You can try that with the stars. I haven't tried that yet, but I made that observation today. I thought, wow, I think I discovered something. Maybe, I don't know. I agree. The sun is apparent, and to me, I just felt like okay, I discovered something maybe here.
Are you talking about parallax?
I don't know what that means, man.